Hey there and welcome to a new video. In this video, we are going to go through 25 SQL interview questions. So once you complete solving the 25 interview questions that are mentioned in this video, you will be able to solve almost any question that you are going to come across in any SQL interview or data related roles. And we will be going through complex concepts like joins, window functions, analytical functions, then common table expression, correlated subquery, normal subquery, joins with exclusion, unions, running sum, cumulative sum, hierarchical query, recursive CTE, lot of concepts which I have mentioned we are going to go through in this video. So try to complete the video without skipping any of the 25 questions and you will be able to solve almost any question that you are going to come across. And once you completely go through all the 25 questions, please share your thoughts on what you think. I appreciate your thoughts and based on that we'll be creating more similar videos. Now let us move on to our first question.
In this video, we will see how to do market basket analysis with SQL or find the items which are frequently bought together from a store. For that, I have created a table called as customer order, which is CUST order, and the DDL to create the table is as follow. And also we have inserted some values into the table. Let us query the table and let me show you the data as well as the schema. From this is the table name, cust order. And the script to create the table as well as to insert the table will be available in the description. You can find it there. And this is the table which we have created, which consists of three columns. First column is order ID, second is customer ID, and the third one is product ID. So product ID specify what are the products brought by a particular customer in a particular order ID. So we will find which are the items which are frequently brought together. We will start with two items which are frequently brought together, and then we will move on to three items which are frequently brought together. Since we have only one table, what we are going to do here is we are going to join the table with the same table based on order ID and customer ID. Select start from, and let us give an alias name C1, and we are going to join the table with the same table and a second alias name C2 on C1 dot order ID to C2 dot order ID. Here I don't have to use the customer ID column because both the customer ID column and order ID column is unique for the particular row. So we don't have to simply repeat the customer ID. Even if I use the customer ID column in the join condition, the result is going to be the same, because if we see the data, we can see that the order ID 111 is corresponding to the customer ID 1, and 2222 is corresponding to the customer ID 2, 3333 corresponding to 3, and similarly those are always unique. So it doesn't matter if I use customer ID in the join condition or not. And for the simplicity, I'm going to filter the data based on a single order ID. Then we will expand it for all the data. So here I'm going to give one more filter, which is C1 dot order ID equal 1111. Now if I run the query, we will get a new table which is based on the join condition. So we have one table which is based on the join condition, that is C1 dot order ID equals C2 dot order ID. So in the result we can see that we don't want the same product ID to repeat again and again. That is, see, we don't want CCCC and CCCC to be in a same row, because that is not going to be a valid combination of product, because both the products are the same products only. So we are going to give one more filter condition here, and C1 dot product ID greater than C2 dot product ID. This is going to filter one more combination, that is, if we see the second combination, that is BBB AAA, and if I come down, we can see that we will have AAA BBB. We don't want this duplicate data also, because these are also the same data. BBB AAA and AAA BBB combination are the same, so we don't want that data also to get duplicated. So we are going to give a greater than condition here. Otherwise we could have given a not equal to condition. So in order to remove this same value combination as well as the reverse duplicate pair, we are going to use the greater than condition here. And now if I run the query, we will get only unique combinations of products. Now we have got the unique combination of product, that is, in the order ID 1, the customer 1 has bought product ID AAAA, BBBB, AAA, CCC, and BBB and CCC. These are the combinations of products bought by customer 1 in the order ID 1111. Now I'm going to remove this filter condition, because we obviously don't want this filter condition, and we are going to do this for the entire data set. And this was filtered only for the understanding purpose. Now if I run this query, we'll get the similar combination for every order ID and customer ID. Now we have got the result. Before moving on to the next part, we will take only the required columns because we don't want this order ID, customer ID to be repeated. But product ID columns are unique columns and are having distinct values. So we will give a new name to the product ID column also. So instead of this star, we are going to use C1 dot order ID and C1 dot customer ID. And from the C1 table, we are going to take the product ID as product underscore 1. This is the first product, and C2 dot product ID as product underscore product 2. Now we have the required columns. Now if we run, we will have only 4 columns which has order ID, customer ID, product 1 and product 2. So these are the combinations, 2 combinations of products bought by each of the customer ID corresponding to the customer ID and the order ID. Now we are going to count the product ID combinations. So for that, we will put this inside a CTE with T1 as open and close the bracket. Now after that, taking reference as T1, that is, now we are going to write query on the table T1. So this is our parent table T1. So select T1 dot product 1 comma T2 dot product 2 dot. Now we are going to use the count as an aggregate function, and we are going to count how many times a particular product combination have repeated as brought together from the table T1. And since we are using the aggregate function, we have to group the column also, so that we are going to use the group by clause, that is T1 dot product 1 comma, see this is not T2, this is T1 only because we only have T1 table, that is the first common table expression, T1 dot product underscore 2. And let us order the result based on the brought together, so that the number which is the maximum should come at the top, that is brought together order by descending. Now let us run the query and see what is the result that we are getting. Oh, it is because I selected the query only till product 2. I haven't included the order by in the selection. Now let me choose the order by also and run the query. Yeah, now we have the result, so that we can see that the product CCC and the product BBB have been bought together 4 times. CCC AAA have been bought 3 times. BBB AAA have been bought 2 times, and all other combinations have been bought together only 1 time. So we can see that this is the product which is commonly bought together. This is for 2 products. Now we want to modify the query for 3 products. Let me show that how he does that. So this is for combination of 2 products. Combination of 2 products. Now we are going to do the market basket analysis for a combination of 3 products. For that, we are going to copy the same query. I'm going to modify the same query a little bit based on the join condition and the number of tables used. So we'll copy the same query, and inside the common table expression, we are going to use one more join condition based on the same customer order table. So after the first join condition, I'm going to use the second join condition, which is for a third customer order table. That is, copy the customer order table, paste it here. I'm going to give an alias name C3, and the join condition is exactly the same. Only thing is we want to change the C2 to C3. That is, the join condition becomes C1 dot order ID equal C3 dot order ID. And inside the where condition, we have to write one more clause, and C2 dot product ID greater than C3 dot product ID. This is for the same reason that I have mentioned earlier. We are using the specific not equal to condition, greater than condition inside the where clause. And also we have to modify the select clause as well in order to include the third product, that is C3 dot product ID as product 3. This is the third product that we are going to use, that is c3.product ID as product 3. And we are now coming to the outer part of the query. Now in this part we are going to use t1 dot product underscore 3, which is the third product, and in the group by clause also we are going to use the same column name product underscore 3. Now we have modified the query for a combination of 3 products. Now let us run the query and see what is the result that we are going to get. Now we have got a result such that we have 4 columns, which is product 1, product 2, product 3, and the number of times the products have been bought together. As you can see, product AAA, BB and BBB and CCC have been bought together 2 times, and product BBB, CCC, DDD have been bought together 1 time. Let us compare the result with our actual table. Select star from cust order. Let us run both the result as well as the parent table, and we can compare the result. Now if we compare the result with the parent table, this is the parent table for the customer ID, customer order table, and this is the frequently bought together result, and we can see that item A, B, C have been bought together by the customer ID in the corresponding order ID 1111. And if we come down, we can see that 2222 is not buying B, so only A and C is coming together, so there is no 3 products and this combination is entirely not considered. And coming down, the customer ID 3 is also not buying more than 2 products, so this is also not considered. And if I come down to the 4th customer, that is corresponding to 4, we have 3 rows, and the items which are bought together are AAA, BBB and CCC, which is same as AAA, BBB and CCC. So this combination of products have been bought together 2 times. And again, if I come down, we can see that 5 customer ID is not having more than 2 products, so this is also not considered when we take the combination of 3 products. And coming down to 6 customer, we have 3 products corresponding to that particular customer, and that product IDs are BBB, CCC and DDD. So in the result we have BBB, CCC and DDD is bought together 1 time, and the first combination is CCC, BBB, AAA, which is the combination bought by customer 1 and customer 4 is bought together 2 times. So this is how we do market basket analysis with SQL. Also we can do this for more number of product combination, and the query might differ depending upon the data model that we are using, but we can modify the data to the similar schema, and we can apply the same logic onto the data to find the frequently bought items together. In this video, we will solve a tricky SQL query which deal with the concept of consecutive days. For that, the question is, write a query to display the records for which more than 100 people are visiting the stadium for 3 or more consecutive days. And we have created a table called a stadium for that. Let me query the table and let me explain the question once again with the table. So the schema of the table is we have ID, visit date and number of people visiting the stadium. And if you see the record, we can see visit date is continuous, that is starting from 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th and continuing till 15th of January 2022. And the ID is also corresponding to that visit date. We have ID starting from 1 to 15. And for every days, the number of people visiting the stadium is recorded corresponding to that ID and visit date. So what we have to find is, we have to find the records for which more than 100 people are visiting the stadium for 3 or more consecutive days. That is, corresponding to each of the visit date and ID, we have to find consecutive days for which the number of people visiting the stadium is greater than or equal to 100. If we inspect the table once again, 5th, 6th, 7th and 8th, we can see that number of people visiting is greater than 100. So these records satisfy our condition such that it is 3 or more consecutive days as well as the number of people visiting is greater than or equal to 100. Also, if I come down for 10th, 11th and 12th also, we have number of people visiting the stadium greater than 100 also. This is 3 consecutive days. So similar records we want to find from the parent stadium table. For that, we will start with the select clause from stadium, and in the question it is given that number of people should be greater than or equal to 100. So initially itself I'm going to filter the parent stadium table with that filter, that is I'm going to use a where clause where people is greater than or equal to 100. Now I will get the records only for which number of people is greater than or equal to 100. That is, if we see the result, we can see number of people for every record is greater than 100 because I filtered the data based on the filter that is where people greater than or equal to 100. So now what we are going to do is we are going to use a row number window function, and we are going to assign a new column for the record that is we are having now. So row number over. So here we are not going to use any partition in the over clause. It is not required because we are going to find the consecutive days based on the entire data set, and there is no partition we have to consider within the data. So no partition I will be using in the over clause, but we will use an order by clause. Order by visit underscore date, and this will be in the ascending order, and we'll be giving a column name as nw underscore id. Now let us run this once again. Now we got a new column that is nw underscore id with the row number corresponding to each of the records which are having number of people greater than 100 or greater than or equal to 100. Now the logic is like we are going to subtract nw minus id from the original id column. Let us do that and inspect the result once again. Then it will be easy for us to understand. So we are going to subtract nw underscore id from the id column. We are copying this entire query for row number, and we are going to give the name as diff. Now let me run the query. Let us see the result. Now if we see the result, we can see that this nw underscore id is subtracted from id, and we are getting a difference column, that is a diff column we are getting based on that calculation. Now we are going to count the records with the help of this new partition that we have created. So if we see the diff column, we can see that 1 is repeating 2 times, 2 is repeating 4 times, 3 is repeating 3 times, and 4 is repeating 2 times. And if we compare this with the visit date, we can see that 2 and 3 are consecutive days. That is, this partition 1 1 is corresponding to 2 and 3. Then if I come down, 4 is not coming in the data, 5 6 7 and 8 is 4 consecutive days, corresponding to that a new partition is created, 2 2 2 2. And again if I come down, after 8 9 is not coming in the data, but we have 10 11 and 12, corresponding to that a new partition is created with 3, that is 3 records. And finally 54 14 and 15, we have 2 consecutive days with a new partition. Now we will count the records based on this partition. For that, I will have to put this query inside a common table expression, or we can use subquery also, but here for easily understanding I will use the concept of CTE because it will make the query simple, and whenever we want we can refer the previous table that we have created. So the initial query we wrote is considered as a common table expression, and after that select start from T1. That is, now we are going to count the number of records based on the partition. Sorry, why I'm getting this error is with T1. After this with T1 I have to put a S. Now it will be correct. Now we are going to count the number of records based on this partition. That is, count star over. Here we are going to use the partition by diff column, and count will be used as a window function here. So partition by diff as conc underscore days, that is consecutive days. Now let us run the query. You can see the result. Now if I come down and inspect the result, we can see 2 and 3, that is 2 consecutive days, are associated with the record, and 5 6 7 and 8, 4 consecutive days are associated with the record, and again for 10 11 and 12, 3 consecutive days are associated with the record, and for 14 and 15, 2 consecutive days are associated with the record. Now in the question it is given that we only want records for which there are 3 or more consecutive days. So we will have to filter the data based on the new column that we have created, that is conc underscore days. For that, I will put this query also inside a CTE expression, that is T2 as. We'll put this query inside a bracket. So after this, select all the columns from the T2 table where conc underscore days greater than or equal to 3. Now let us run this query and we'll get only the records for which conc underscore days, that is consecutive days, is greater than or equal to 3. Now if we see, we can see that we have records for which we have number of consecutive days are greater than or equal to 3. In the final result, we don't want these calculated columns to appear, so we are going to query only the columns which we require in the result, that is ID, visit date, and people. So instead of this star, I'm going to use ID, comma visit date, comma people. Now let us run the query once again and see the new result. Now we have result for which records for which number of people is greater than or equal to 100. Also, the consecutive days are either 3 or greater than 3. That is 5, 6, 7, and 8 have 4 consecutive days where number of people is greater than or equal to 100, and 10, 11, and 12 3 consecutive days where number of people is greater than or equal to 100. The same query we can write with the concept of subquery also with minor modifications. In this video, we see a tricky question which deal with resetting the running total when the running total becomes negative. So for that, we will be using the table sample superstore. Let me query the table and then I will explain the question. So we have multiple columns in the sample superstore table. To solve the query, we will be using two columns, namely which are order date and profit. Because our question is to reset the running total when the running total profit become negative. So let us start writing query for the same. Select, we want order date and profit from the sample superstore table. Let us run this query and select only the required columns. So we have the two required columns which are order date and profit. Also let us order the result based on order date. Then let us see the duplicate order dates, and second, third, and fourth record we can see that all the three records are having same dates but with different profit. So what we have to do initially here is we have to use the sum aggregate function on the profit column, and we have to find the profit made by the company on each day. For that, on the same query, I'm going to use the aggregate function on profit. We'll rename the column as total profit. Also, we'll use a group by clause after the from clause on order date. Now let us run the query and we will get the aggregated total profit for each day. Now if we see the result, we can see that each of the rows are having unique records, that is each of the order date are unique in the result. Now let us find the running total of the total profit column. Let me put this inside a CTE so it will be easy for us to understand. With T1 as, so the name of the first CTE is T1. Then we are going to do a running sum on the total profit column. So I'm taking all the columns from the T1 CTE table, and the next step is to calculate the running sum on total profit over. So we are inside the over clause, we are going to use the order date with the order by clause, order underscore date in ascending order. It is not necessary that we specific ascending always, because by default it is ascending, but to be obvious it is always good to use the proper syntax as running profit sum, and this is from the table T1. And also before running the query, let us make sure that we comment out this order by clause within the CTE, otherwise you will get an error. I will show that. Let me run the query without removing. If I run the query, see the order by clause is invalid in the view, you will get similar error. So what we are going to do is we are going to comment out this order by order date clause inside the CTE, and we are going to copy this to the outer query. Now let us run the query and we will get a running sum based on the total profit column. Now if we see the result, we can see that, see, whenever the total profit is becoming negative and it is having a very big value, our running profit sum is also becoming negative. This is not good. The question is asking us to find or reset the running total whenever the running total profit become negative. So what we are going to do here is we are going to use a case statement and going to create a flag based on which we are going to then create a partition and then create a running sum or running profit based running total of the profit column or the total profit column. So we will put this query which we wrote also inside a CTE. So the name will be T2 as inside the second CTE also, that is T2 also, we are going to remove the order by clause. Then we are going to put a flag based on the total profit column, that is T2 star. We are selecting all the columns from the T2 table and using a case statement, case when total underscore profit is greater than or equal to 0, then, so one thing is, before creating the flag, there is one condition that we need to satisfy. So for that only we are using this case statement. So whenever the total profit column we have a negative value, we will replace that total profit negative value with a 0. So that is the case statement that we are going to write now. That is case when total profit greater than or equal to 0. Then let us take the same value in the total profit column. And whenever the total profit column is less than or equal to 0, we are going to replace it with a 0. So the condition is total profit less than 0. Then we are going to replace the total profit negative value with a 0. Then end as new profit, renaming the column as new profit, and this is from the table T2. And let us use an order by clause also here, copying the order by clause from the previous query because the column name is same. Now if we run the query, we can see that all the negative values from the total profit column has been replaced by 0, and all the non-negative values are carried over or which are same. So we will keep this query also inside a CTE, that is we will name it as T3 as, then we will use a bracket to put the entire query inside the CTE, and we will comment out the order by clause within the CTE. Now we are going to create a flag based on the new profit column, that is select T3 dot star, then case when whenever the new profit is 0, we are going to put a flag 1, and whenever it is not 0, we are going to flag it as 0. So case when new underscore profit is equal to 0, then 1, and or else 0, and we are ending the case statement as, and rename case state, we are ending the case statement and naming it as flag. So this is the flag which we are going to use as the partition clause. Now this is from the table T3, and we will use an order by clause also here. Now let us run the query and see what is the result. Now we got a flag column which has the one or 0 based on the new profit column. That is whenever the new profit column is having a 0 value, the flag is 1, and otherwise it is 0. Now we are going to use a sum aggregate function on the flag column, and we are going to create a new partition column. So we'll put this query inside a subquery, sorry, in a CTE. Then select T4 dot star, then sum of flag over. Now we don't have to use any partition clause, instead only order by clause we have to use inside the over clause. So order by, that is order date column we are using in ascending order. And naming the column as sum flag, and from the CTE table T4, and using an order by clause on order date. Now let us run the query, and we can see that we got a new column which is the sum of flag. From this we can see that a new partition is created whenever the new profit is becoming 0. That is, for new profit the sum of flag is 0, and when it becomes 0, or it has got a negative value, it went back to 0, and a new partition is created 111 until again the value is becoming 0. That is negative for the total profit column, but we replaced it with a 0 since I am calling it as 0. And again if I go down, we can see that again when the new profit column we have a 0 value, the sum of flag has been resetted and we got a new partition. Now we are going to create a running total based on the sum of flag column using as a partition, and in the order by clause we are going to use the order date. So the latest query also will put inside a CTE T5s, then commenting out this order by clause, select all the columns from T5 CTE, sum of, that is we are going to take the sum of new profit column, new underscore profit column, over, and the partition we are going to use here is the sum of flag, partition by sum of flag, order by is same, which is order date. We are going to use the order by clause on the order date column in the descending order. Sorry, not in descending order, in the ascending order, because it should be from small to big. We are going to name the new column as reset profit, and this is from T5 CTE, and again we are going to put an order by clause. Now if we run the query, we can see that we will get a new profit column which is reset underscore profit. So whenever the total profit is becoming negative, it is getting reset to 0 and again calculating from the beginning. That is, the first value compared to total profit is 5.55. The reset profit is also 5.55. Then coming down, it's minus 65. The reset profit has become 0. Coming down, it is 4 for total profit, 4.8. Then coming to reset profit, it is 4.88. Then coming down, it is 1358. And if I come to the reset profit, we can see that it is 1362, which is the sum of 4 plus 1358. And again, if I come down, we can see that similar condition is getting satisfied, and it is taking the sum of total profit column, excluding the negative profit values. This is how we reset the profit column whenever it becomes negative.
In this video, we will solve a query which is frequently asked during interviews. The question is, find the employees who are earning a salary greater than and less than the average department salary. And there is a specific condition which is given, that is, in the query which we write, we should not use join and window function. So the query should not contain any type of joins or any type of window function within the query when we write the query to find the employees who are earning a salary greater than and less than the average department salary. So our input table is called as employee underscore salary, that is EMP underscore salary. Let me query the table and let me show you the schema. So our input table has 4 columns which are ID, name, salary and department ID. Also, our expected output looks like this table. That is, the expected output should have 2 new columns which are average department salary and average department salary indicator, which indicates whether the salary for that particular person is higher than or less than the average department salary. So this is our input table, exactly the same input table plus 2 more columns which are average department salary and average department salary indicator. Also given that we should not use join and window function. So let us start writing the query. So we'll start with select clause, and the first column is ID, second column is name, third column is salary, and the fourth column is
department ID, and this is from the table employee underscore salary, EMP underscore salary. And now if I go back to the expected output, what we want is we want an average department salary. So we want one more new column, that is average department salary. So here is the tricky part comes. So we should not, it is given that we should not use any join or window function. So what we will do is we will write a subquery to specify the column value. So I will open and close a bracket, and inside the bracket I'm going to write a subquery. So that is select average of salary from the table is same table, that is EMP underscore salary, and inside the subquery we are going to give a where condition. That is, so before giving the where condition, let me give an alias name to the employee salary table which is outside the subquery, that is E1, and also the employee salary table which is inside the subquery I'm going to give alias name as E2. So in the subquery after the where clause we are going to write a condition, that is E2 dot department ID equals E1 dot department ID. So this is the where condition inside the subquery, and we are also going to give an alias name, the same name that we are using here, that is average department salary. Let me copy the name, we will use that name, that is average department salary is the column name. Now let me run the query and let us see what is the result. So now we have the first column that we saw in the expected result, that is average department salary. Now what we have to do is we have to compare the salary and average department salary, and we have to create one new column, that is average department salary indicator. If the salary is greater than the average department salary, we should mark the salary as higher, and if the salary is less than the average department salary, we should mark the salary as lower. So now we have to find the difference between the salary and average department salary. So after the average department salary column, let us write one more column, that is salary. This salary is from the table E1, that is the table which we have mentioned in the outer query, E1 dot salary minus the subquery which is written inside the parenthesis. So we'll copy the same thing and we'll paste it here, that is E1 dot salary minus select average of salary, this is E2 dot salary. I will mention here also E2 because then it will be easy to identify. E2 dot salary from employee salary, the alias name is E2, where E2 dot department ID equal E1 dot department ID. So this is the difference between the salary and average department salary. Now let us run the query and see what is the result. Now we have a new column which has the difference between salary and department average salary. So here it is like 85,000 minus 79,800 gives 5,200, and if I come to the third row, which is for Sam, it is 60,000 is the salary and the average department salary is 70,000, so the difference is minus 10,000. So now we have to show whether the salary is greater than or less than the average department salary. So we will put the entire query inside a bracket or parenthesis, and we will use a case statement, that is case when this value is greater than 0, then we are going to mark it as higher, else we will mark it as lower, and we will end the case statement and also give an alias name which is same as the column name in the expected output. So we can give any column name. I am just using the same column name to compare it with the final result. So our column name is average department salary indicator. Now let us run this query once again and see what is the result. Now if we compare the expected output with the output we have obtained, we can see that we have the exact same output, which is having two new columns, which is average department salary indicator, that we have obtained as per the requirement. In this video, the question is write a SQL query to find all the employees from employee table who are also managers. So from the question we know that we only have one table, that is the employee table. From that, we have to find the employees who are managers. So for that, we have created a table, which is the employee table. So this is the DDL command, and this is the DML, which I have used to insert records into the employee table. The two commands I will provide in the description, so you can create the table. So the table name is employee. So let me query the table and let us see once again the schema, and we'll solve the query. Start from employee. Let me execute the query. So this is the table that we are going to use. We have an employee ID column, first name, last name, salary, joining date, department, and manager ID. So the question is to find all the employees from employee table who are also managers. So we have an employee ID column and a manager ID column. So each employees are mapped to a manager. So we have to find who are the employees who are also managers. So if I take the example of the first employee, which is James, James manager is having an ID of 2, that is employee ID 2, that is Jessica. So Jessica is James manager. So Jessica is a manager. Similarly, if I take the manager of Jessica, that is employee with an employee ID of 5, that is 5. If I come down, we can see Christine. So Christine is also a manager. So we have to find all the employees from the table who are also managers. So we'll start writing the query, and from the table we only want the first name and last name of the managers. So we'll write the query in such a way that we will only take the first name and last name. So select first name, then we'll take the last name, and here the technique we are going to use is self join. That is, we are going to join the employee table with the same employee table using two different columns that I will show. So the first time we are going to use employee table and giving an alias name of A, and we are going to join this employee table to the same employee table and giving an alias name B and on. So here is the tricky part where the in the join condition. So here we are going to join the employee table, first employee table and the second employee table based on the employee ID column and the manager ID column. So the condition is A dot employee underscore ID equal B dot manager underscore ID. So we are joining the first employee table A using the employee ID column to the second employee table, that is B, using the manager ID column. So now if we run the query, we'll get only the employees who are also managers. So let me run the query. Now we have an error, incorrect syntax near keyword from. It is because I put an unwanted comma after the last name. So if I remove that, we should get the expected result. Now we have a second error because we have ambiguous column name first name and ambiguous column name last name, because from both the employee table we have the columns, that is first name and last name. So the query do not understand from which table it has to fetch the first name and last name column. So before simply executing the query, what we have to do is we have to give the alias name of the table in front of the column name. So A dot first name and A dot last name, and this will solve the issue. Now if we run the query, we'll get the result. So now we can see that the first name and last name of managers from the table we got, that is these employees are also managers. So Jessica, Christine, which we initially saw, and Jennifer. So these three are managers from the given employee table. In this video, write a SQL query to find employee with the highest bonus. So we have to find the employees first name, last name, department and bonus from the two tables, which are bonus and employee. And the DDL and DML to create both the tables will be provided in the description. So this is the employee table that we are going to create, and this is pretty straightforward without any complexity. Only thing is we are defining the employee ID as the primary key with the identity constraint, and also we are providing a not null constraint here, and this is the DML command which we are using to insert data into the employee table. And coming down, we have a bonus table. Here also we are using one constraint for the employee reference ID, that is foreign key constraint. So this employee reference ID column is mapped to the employee ID column in the employee table. So this employee reference ID acts as the foreign key. So there is a relation between the employee ID and the employee reference ID in the employee table and bonus table. So this is something we have to take care. And coming down, we have the DML command which we use to insert data into the table to the three columns: employee reference ID, bonus amount and bonus date. Now coming back to the question, Let me query both the tables, and once more I will show you the schema. So the first table is the bonus table, which has three columns, which is the employee reference ID, bonus amount, and bonus date. And we have the second employee table where we have employee ID, first name, last name, salary, joining date, department, and manager ID. Here from the DDL it's clear that we have mapped the employee reference ID and the employee ID column of both the tables. So the basic relation between the two tables are using the employee ID columns from the both the tables. Now the question is to find the employee with the highest bonus. So the first thing we have to find is what is the total amount of bonus that each employee has received. So for that, let us start writing the query. Select, the column is employee ref underscore id comma sum of bonus amount as total bonus, and this is from the table bonus. And since we are using an aggregate function, we'll have to use a group by clause also. Group by employee underscore ref underscore id. Now if we run the query, we'll get the employee and the corresponding total bonuses earned by each employee. So from the bonus table corresponding to each employee, the first employee has earned 9,500, the second employee 6,500, and the third employee 4,000. Now the question is given that we have to find the employee with the highest bonus. That is only one employee we have to find who has earned the highest bonus. So it is clear from the table that we have obtained that the employee with the ID 1 is receiving the highest bonus, that is 9,500. To get only that from the particular result, we are going to use a top 1 clause inside the select clause, that is top 1 followed by the same query, and after the group by clause we will put one order by clause also, because always we want the result in the descending order of the total bonus, that is order by total bonus DSC. Now we will get only one employee from the result. So now we have employee reference ID 1 and the corresponding total bonus. Now we have to find the first name, last name, department, and bonus from the employee table, because all these are available only in the employee table and the bonus table does not have any of the data requested in the question. So let us keep this inside a CTE. This is T1. Now let us simply select all the result from the T1 table. Now we will see exactly the same result. Now what we have to do is we have to join the result with the employee table. So instead of this star, what we are going to do is we want first name, last name, department, and the total bonus. So with the employee reference ID and the employee ID which is available in the employee table, we are going to join the table. So T1, from T1 join employee table, and we will give an alias name as E on T1 dot employee underscore ref underscore ID equal E dot employee underscore ID. Now we have joined the two tables using the employee ID columns. Now let me run the query and let us see the result. Sorry, we have an invalid column name because one O is missing after the employee. Yeah, now we should get the result. Now we have the result. Employee reference ID, total bonus, employee ID, first name, last name, salary, joining date, department, and manager ID, corresponding to the employee who is earning the maximum bonus. But from the question it's given that we only need the first name, last name, department, and bonus. So instead of the star, we are going to take the E dot first name, because that is coming from the employee table E, this one, and the second thing is E dot last name comma and E dot department comma, and the final one is bonus. Bonus we have to get from the T1 table, that is T1 dot total bonus as bonus. Now we will only have the particular columns which are mentioned in the question in the result. Now we have first name, last name, department, and the total bonus received by the employee who is having the highest bonus.
In this video, we will solve a complex SQL interview question. For that, we are going to create a table called as vehicle. And for the vehicle table, it will be having three columns. The first column is car ID, which is an integer and is going to be the primary key column and will be assigned one more constraint, that is the identity constraint. The second one is company column, which is a variable character column, and the third one is a car column, which is also a variable character column. And then we are going to insert data into the vehicle table. First of all, let us go ahead and create the table and insert data into the vehicle table. Then let us see what we are going to do here. So we have completed creating the table and also we have inserted data into the table. Now let us query the table and see what is the data within the table. So select star from vehicle and we have the three columns and the data. We are going to try and populate the last non-null values from the company column into the rows whichever is having a null value. So for example, if I take this first record as an example, Mercedes value should be populated to all the null values following the Mercedes row. Similarly, when coming to OD, the next two null values should be populated by OD, and when coming to Lexus row, which is the 8th row, the 9th and 10th row, which is having null value for the company column, should be populated by Lexus. That is what we are going to try and accomplish here. Let us start writing the query. So we'll start with a select clause. Select the column which we require are company, car ID and car name. So the first column is company, then let us take car, then the other column is car ID column. Now what we are going to do here is we are going to create a new row number based on the row number function. Row number over, we don't want a partition clause here, we only want a order by clause here. Order by car ID column in ascending, we'll give the name as new underscore ID, and this is from the table, vehicle table, and after that we will give a where clause, and we want only records which has a null in the company column, where company is null. Let us run and see what is the result. We have the result for which only null values are appearing in the company column. Now let us keep this inside a CTE, that is our first CTE, that is common table expression. So with CTE1 as the below query, then coming down, let us join this table to the first vehicle table, that is the initial vehicle table. Select star from vehicle table, let us do a left join. CTE1, that is on vehicle dot car, we are going to join the table based on the column car. CTE1 dot car. Now let us execute the query and see what is the result. We have a new table being created which contains the new ID column which we created using the first CTE. Now let us take only the required columns from this table. So we don't want all the columns, we only want vehicle dot car ID, then the second column is vehicle dot company, comma, next column is vehicle dot car, and from the CTE we want the new ID column, CTE1 dot new underscore ID. Now let us execute this once again. We have got some error, there are some typo mistakes, let us correct that. So yeah, it's vehicle, it's not VHCILE, and the second error is the same thing. Now also we have to change the company name, PANY. Now it should be giving the result. Now we have the 4 columns which are required for further processing. Now let us create a new calculated field where we subtract car ID from the new ID column, that is vehicle dot car ID minus CT1 dot new underscore ID. Let us see what is the result we are getting, and let us name this column as new partition. Execute this. We have a new partition column created based on which we will do partition in the further processing. So when we see the result, here we can see for the record which is having Mercedes, the new ID is null and new partition is also null. But for all the 3 records below the first row, we have new partition as 1. So what we can do here is, if we had a 1 in the first column as first row as well for the new partition, we could have used the first
value window function in SQL, and we could easily get the Mercedes value to get populated to all other null rows below the first row. Now we will modify the new partition calculation because we require 1 corresponding to Mercedes. For OD, instead of this null we require 2, and for Lexus instead of this null we require 3. For that we are going to process this calculation a little bit. For that we are going to modify this CTE1.newID column. So we will take a if condition, that is if CTE1.newID is null, comma, then let us use a lag function, lag CTE1.new_id over, we don't want a partition, just a order by clause, order by vehicle dot car underscore id. And if the condition is not true, we want the CTE.newID column only in the result, that is CTE1.new_id. Now let us run this once again and see what is the result. Now we have 2 corresponding to OD and 3 corresponding to Lexus, but one thing did not got changed, that is the Mercedes even now is having null for the new partition. For that let us write a case statement here, that is case 1 vehicle dot car underscore id equal 1, then 1, else the equation which we have created. And finally we will end the case statement with an end clause. Now let us run the query and see what is the result. We have the same error once again. It is because of the typo error VEHICLE. Now we should have the result. Execute this and we have the new partition which is created based on our requirement. Now let us take only the columns which are required for further processing. That is, we require the car ID column, company, then vehicle car. We don't want the new ID column. Let us comment the new ID column. Execute this and we have the result which is having 4 columns. Let us keep this query inside a second CTE, CTE2 as. Now let us use the first value function from SQL. Select company, comma, car, comma, first underscore value, open and close parenthesis, and put company inside the parenthesis over. Partition is based on the new partition column which we have created, that is partition by new underscore partition. Order by clause is based on the car ID column, order by car underscore id in ascending order, and this is the new company column, and this is from the previous CTE, that is from CTE2. Let us execute and see what is the result we are getting. We have the new company column which is created and which is being populated with the previous non-null value ordered based on the car ID column. Let me query the car ID column also here, car underscore id. Execute this and we have the expected output. Let us remove this old company column also from the result and let us once again run the query, and this is the result that we were looking for. In this video we will solve a tricky SQL interview question. Our question is, write a solution to display the records with 3 or more rows with consecutive IDs and the number of people is greater than or equal to 100 for each. This is our question. So I have created one table called stadium on which we are going to solve the query. This table has 3 columns that I have already queried here, which is ID, visit date and people. So basically what this table tells us is the number of people visiting a stadium on a given day. For example, the first record corresponding to ID1 on 2020 January 1st, 10 people are visiting a particular stadium. On 2nd of Jan, 109 people are visiting the stadium. Similarly, we have 8 records corresponding to 8 days. Now, we have to write a solution to display the records with 3 or more rows with consecutive IDs and the number of people is greater than or equal to 100 for each. So we have to find the days for which the number of people visiting the stadium is greater than 100 and the ID should be consecutive, because in our data there is one specific case where we have 2020 January 7 and after that 8th is missing and the next date is 9. So both the days are having people visiting the stadium greater than 100. So this is a valid condition because from 5, 6, 7 and 9th we have 100 people visiting the stadium. So the condition is given like the number of people is greater than or equal to 100 for each, and the record with 3 or more rows with consecutive IDs. So here the IDs are consecutive, hence this is a valid condition. Now let us start writing the query. So we will start with a select clause, select ID, comma, visit date, comma, people, that is number of people visiting the stadium. Now we will use a window function, which is the row number function, row number over, we don't have to use a partition here, but we need an order by clause, order by ID. The default order itself is ascending. Let me give a name which is new ID, and from the table stadium. Now let me execute this. But in the question it's given that the number of people should be greater than or equal to 100. So let us filter this query with a where clause. Number of people should be greater than or equal to 100. Now once again let me run it. Now we have a table with 6 rows. Earlier we had 8 rows. Now I will introduce one more calculation here, which is ID minus the entire function with row number. Now put this inside a parenthesis, and I'm going to give a name as flag. Now this is a partition that we are going to use to solve the query. Now executing this once more, a new column will be created called flag, which is basically a partition, and this partition actually we can use to count the number of consecutive days. Now if we take the example here, based on the ID, 2 and 3 are continuous IDs, so corresponding to that the number of people are 109 and 150. So we have a flag of 1 1, so we can count the number of ones. Now coming down, after 3 there is no 4, it's 5, 6, 7 and 8. Now if we check the flag column, we can see that the partition is 2, 2, 2 and 2, that is 4 2s. Now this is a second partition where it's a valid case, where we have number of people greater than 100 and number of consecutive IDs are greater than or equal to 3. Now using this as a common table expression, T1 as, that is the first query. Let us write a second query, that is select star, comma, let us use the count function as a window function here, that is count1 over partition by the flag column which is created. We don't have to use a order by clause here, just partition by should be fine. Then giving a column name as days count, and this is from the table 1, that is CTE1. Let us execute this once again. Yeah, we can see that now we have got a new column with the days count, that is consecutive days count. So corresponding to ID 2 and 3, the consecutive days are 2, and corresponding to ID 5, 6, 7 and 8, the number of consecutive days are 4. Now we can do one more CTE, that is T2 as, comma. Now after that, let me go through the question once again, that is write a solution to display the records with 3 or more rows with consecutive IDs. So we want all the records corresponding to that particular condition. So select, we want ID, comma, visit underscore date, comma, number of people visited. So these are the 3 columns which we have from our initial table, that is the parent table, that is from T2. Now if we execute this with one more where condition that we have to put, because we want to filter the records based on days count, that is days underscore count greater than or equal to 3. Now executing this will give us the intended output, but we have an error. This is because we have a query before this common table expression query. So any query before the common table expression should be ending with a semicolon. Now execute. We will get the result. So this is our input table and this is our expected output. That is the days where the number of people is greater than 100 and the IDs are consecutive.
In this video, we will solve a complex SQL interview question. The question is, write a solution to report the customer IDs from the customer table that bought all the products in the product table. So we have created two tables which are customer table, that is customer underscore prod table, and the product table which is the product underscore list table. So we have to find all the customers from the customer table who bought all the products listed in the product underscore list table. Let us query the table and see what are the columns available. So in the customer underscore prod table, we have two columns available. The first column is customer underscore ID and the second one is product underscore key. So this table tells us which customer bought which product. And the second table is product underscore list table. And product underscore list table contain all the product keys. So whatever products are available within that particular store, that product key will be available in the product underscore list table. Now we have to write a query to find all the customer ID from the customer table who bought all the products which are available in the product underscore list table. So let us start writing the query. We'll start with a select clause. Select. Now what we want is we want all the customer ID from the customer underscore prod table. So we will use customer underscore ID. Now this is taken from the customer underscore prod table. Now what we want is we want the count of product keys from the prod table. So before that, let us give a group by clause. Group by customer ID, customer ID. And now after that, we have to use a having clause. Before providing having clause, let us use a count function here so that it will be easy for us to understand. Let us give count star, or let us use count distinct product keys, which will give the number of product keys assigned or bought by a particular customer. That is product key as product count, that is product count. Now after this group by clause, let us give a having clause, and after the having clause, let us give a condition using count function. That is, let us copy this count distinct product key equal. Now we have to count the number of product which are available in the product list table. That is, select count of, let us use the same clause which is distinct product underscore key, and this is taken from the table product list table, this table, second table, product underscore list. Copy and paste it here. Let us use a parenthesis to put the entire query. Now let us run this and we'll get customers who bought all the products. Now we can see that customer 1 and 3 bought all the products which are available in the customer underscore prod table. But in our output we only want customer ID, so we can remove this part of the query which is the count distinct prod underscore key as prod count. We don't want that, so we can remove that. Now we'll get only customer ID from the customer underscore prod table. Now let us analyze the input once again. The answer we got was 1 and 3. When we analyze this table, we can see that customer 1 bought product 5, customer 1 again bought product 6. Similarly, customer 3 bought product 6 and customer 3 bought product 5. When we come to product list table, we can see that the product keys which are available in product list tables are 5 and 6. So 1 and 3 bought both the products which are 5 and 6, and 2 have only bought product 6 and 2 did not bought product 5. So the output should be 1 and 3, and we got the output as 1 and 3. Now we have the required output, but even though we got the correct answer, there is a problem with this query. Here we are taking the count of distinct product keys from the product list table. So whenever the count matches, we will get the output. So that is not a valid case. So what we can do is, let us see that first. So here I'm going to truncate the product list table, product underscore list table. Let's remove all the records from the product list table. So we have removed all the records from product list table. Now let us insert two new records into product list table, which are 8 and 9. Now let us run this query and see what is the input table having. Now we can see that the customer underscore product table is unchanged. It has the same input. Now the product list table, I have changed the input keys. The product keys are now 8 and 9. But even now when we run the query, we'll get the output as 1 and 3. Let us execute that once. See, we got the output as 1 and 3, but this is wrong when we analyze the input. There are no customers who bought product 8 and 9 from the product list table. So this query is giving us wrong result because it is not taking into consideration the actual record. It is only taking into consideration the number of records or the number of product keys. In order to remove this limitation, actually we can write a second query which is even better than this query and will give us the right answer in all the conditions. Now before that, let us truncate the table once again and let us insert the actual records into the product list table, which are 5 and 6. Execute this. We have inserted the actual records. Now let us start writing the second query, that is method 2. Here the first thing what we are going to do is we are going to create an ideal table where every customer has bought every product. So select customer underscore id from the customer underscore prod table. Now let us cross join this table with the second table, that is cross join select product underscore key from the product list table, product underscore list table. And before running this query, we have to make some more changes. We only want distinct customers from the customer prod table. So distinct. Now let us put this inside a parenthesis because we are using a cross join to join the two tables. And from the second prod underscore list table, we'll do the same thing. We only want distinct product keys from the prod list table. Distinct product key from the prod list table. Let us put this inside another parenthesis and give an alias name P. Now select star from the below two tables which are cross joined. Execute this and we will get the ideal table in which every customer has bought every product. That is, one has bought 5, 2 bought 5, 3 bought 5, then again 1 bought 6, 2 bought 6 and 3 bought 6. This is an ideal case. Now let us join our actual input table with this table. So the first table will put this inside a parenthesis. Sorry, not a parenthesis, inside a CTE. Inside P1 as. Let us put this inside a CTE. Now let us join the actual input table with this table. So select, let us put star for now, and from P1 let us do a left join is customer underscore prod table, and let us give an alias name as CP, and here we will give the join condition on P1 dot customer underscore id equal cp dot customer underscore id. We'll copy this. Instead of P1, substitute cp. The second condition is P1 dot product underscore key equal cp dot product underscore key. So instead of this T1, substitute cp. Now we have joined the two tables. Let us execute this and see what we are getting. Execute this. Yeah, we have a new table in which we have all the customer product combination from the tables along with the actual records from the customer underscore prod tables. Now what we can do is we have to use a where condition to fetch the record only for which the customer id and product key from the actual customer underscore prod table is null. For that, what we will do is here we will write where customer from the cp dot customer underscore id is null. and CP dot product underscore P is null. Now we will execute this and we will get the record only for which the customer ID and product key is null from the current result we are having. Now we will execute this. Now we have a customer ID and product key for which customer ID and product key is null in the actual customer underscore prod table. Now we want the customer ID from this table. We want only customer ID from this result we have obtained. For that, instead of this star, we will substitute T1 dot, because this customer ID and product key belongs to T1, which is this first CTE. T1 dot customer underscore ID. Now we have the customer ID, which is 2. Now execute this. Yeah, we have the customer ID. Now let us put this inside the second CTE, that is E to us, this one. Now we will use a except clause in SQL. That is, we will write first select. We will take all the distinct customer ID from the actual customer underscore prod table and except select distinct customer underscore ID from T2. So here what the except clause does is, except clause removes the customer ID which is available in the CTE T2 from customer prod table customer IDs. So when we run this, we will get some customer IDs who bought all the products. Now let us run this and see what is our output. Execute this. Now we have the customer ID 1 and 3. So these are the customers who bought all the products from the store, which is from the prod underscore list table. Now let us truncate the table and see what this query does for the condition which we saw earlier. So we'll first truncate the table, truncate table, prod underscore list, and instead of this 5 and 6, we will insert 8 and 9. And for this records, let us see what our new query is giving. Now let us run this. Ideally, it should not return any result. Execute this. Now we have no result. So this query tells us that even though the product list table contains two products which are 8 and 9, none of the customers has brought the product 8 and 9, but customers has bought different combinations of product. So this query will give us the right answer. So we can use this query instead of the first query which we wrote using count and having clause. In this video, we will solve a tricky SQL interview question. The question is, group sold products by date. For that, I have created a table called as activities, and we are going to try and write a solution to find for each date the number of different products sold and their names. Let us query the table and see the table schema and the expected result. Then it will be easy for us to understand. So this is the input table, that is activities table with two columns. The first column is sell date and the second column is product, which tells us what is the product sold on a particular date. Also a condition is given, that is the activities table can have duplicate rows, which means same product can be sold two times on the same day. For example, on 2020 5:30 t-shirt is sold, and again on the same day t-shirt is sold again. So that is recorded twice. So this is considered as a duplicate record. So when writing the final query, we have to take care of this duplicate record. And also our expected result is in this format. That is, we have the sell date as the first column and the products sold, that is the number of products sold on that particular day, and the list of products sold on that particular day, which are separated by a comma delimiter. Now this is our input table, which is the same input table which we saw earlier. So on 35/20/20, the products sold were headphone, basketball and t-shirts. Two times t-shirt was sold. So when we are coming to the expected output table, we can see that the three products or three different products were sold on that particular day, and the products column is concatenated with three product names, that is basketball, headphone and t-shirt. Similarly, on different sell dates, number of products sold should be recorded along with the product names. So this is the format of our expected output. Now let us start writing our query.
Let us start with a select clause, and in our output the first column that we want is sell date. So we'll take the column sell date from the activities table, that is sell date, and the second column that we want is number of product. For that we are going to take the count aggregate function, and inside the parenthesis we will use product name. So that is the second column, and the column name should be product count underscore count, or the number of products sold. Now the third column should be all the product names concatenated into a single row. For that we are going to use a function called as string aggregate function, that is string underscore agg, and inside the parenthesis the first argument is product column, that is product name. The second argument is the delimiter comma, that is comma. Now we'll close the parenthesis and give the column name as products. Also I have noticed one more thing here. The column name is wrong here. Let us correct it. Yeah, it is product. Yeah, now it is correct. Now this is taken from the activities table, and we have to use a group by clause since we are using two aggregate functions, that is group by. The column is sell date. Now let us execute this query and see our output. Execute this. We have an output. Let us compare this with our expected output and see if there is some difference. Let us paste it here and let us compare it with the expected output. On sell date 30/5/2020, the product count is 4, but in our expected output we have 3. It should be 3. And in our product name column, it is headphone, basketball, and t-shirt has been specified 2 times. So we have to take care of this condition. This is the condition which I initially mentioned. That is, we have to take care of the duplicate data when writing the final query. Now let us go back and correct that. So instead of these activities, what we are going to do is we are going to write a subquery. That is, we will write a select clause, select. Now we'll use the distinct function, that is distinct or from the activities table, and we'll give an alias name A. Now what this does is this select distinct star from the activities now will only take the distinct records from the activities table. Now if I run the subquery, we can see that sell date and product have only unique records, that does not have any duplicate record. Earlier we had two records for this 2025-30 t-shirt, and there was one more record which was duplicated because the product was sold 2 times on that particular day. Now when we ran this query with a select distinct, we only have unique records. Now let us run this query and see if we have our expected output. Now we have this output. Let us copy this. Let us compare with this our expected output. Now we have the expected output and our output matched. So we have sell date as 35/2020, product sold is 3, that is 3, and the products are basketball, headphone, and t-shirt, and the expected output is also same. In this video, we will solve a meta SQL interview question. The question is friend request acceptance rate by date. What is the overall friend acceptance rate by date? Our output should have the rate of acceptance by the date the request was sent, and we have to order the result based on earliest date to the latest date. Let me query the table. Let us take the table and I will explain the question once again, then it will be clear. So this is the table which we are going to use, which is the FB underscore friend underscore request. It has got 4 columns. The first column is user ID sender, the second column is user ID receiver, the third column is date, and the fourth column is action. I will explain it with a sample table which is created in Excel. So we have the same table replicated here, which has got 4 columns: user ID receiver, date, and action. So the user ID sender is the person who is sending the request. User ID receiver is the person who is receiving the friend request. And this is the date on which that particular action is happening. The action can be either the person is sending the request. Second instance, we can see that the action can be accepted, which means the friend request sent on 4/1/2020 by the user ID to the user ID receiver has been accepted on 6/1/2020. So the action column can have different values which are sent and accepted, and the date can be the send date or accepted date. Now we have to find the
user acceptance rate based on the date which is sent. So our output should contain the date sent column along with a new column, that is the acceptance rate column. So these are the two columns which we require in our output: the particular date on which the request is sent and the acceptance rate based on that particular date. So now how do we calculate it from this table? Now if we take the first example, we can see that these two instances are for the same user ID sender and user ID receiver. And on date 4/1/2020, the user ID has sent the friend request, and on 6/1/2020, the user receiver has accepted the request. Similarly, if we take the third and fourth record, these are for the same sender and receiver pair. We can see that on same date, that is 4/1/2020, the user has sent a request to the receiver, and on 15/1/2020, the receiver has accepted the request. When coming to these two records, we can see that again on 4th, the request has been sent by the sender, and on 10/1/2020, the receiver has accepted the request. And when we come down to this record, we can see that this has got only one instance. The user ID sender and user ID receiver pair has got one instance, because on 4/1/2020, the user ID sender has sent the request, but the user ID receiver or the receiver haven't accepted the request. So now we inspected the entire table and we saw that there are 4 instances where on date 4/1/2020, there are 4 requests which have been sent. So these are the 4 instances. This is the first one. So let us color it in red. So this is the first record. Then this is the second record. Then this is the third record. And this is the fourth record. So there are 4 friend requests sent on 4/1/2020, out of which only 3 has been accepted. That is these 3. On 6/1/2020, one of the friend requests has been accepted. So this is one example. So on 15/1/2020, another request has been accepted corresponding to this record. On 10/1/2020, another friend request has been accepted, which was sent on 4/1/2020. So for the last request which has been sent on 4/1/2020, it has not been accepted yet. So there are 4 requests sent on 4/1/2020, out of which 3 has been accepted. So here the acceptance rate will be 3 divided by 4, which means the number of friend requests which was accepted and which were sent on that particular day, which is 4/1/2020, that is 3, divided by the total number of friend requests sent on that particular day, that is 4. So we divide these two numbers and we will get a acceptance rate of 75%, which is 3 divided by 4, which is 0.75, which we will convert into percentage, that is 75%. So that is how we will calculate the acceptance rate here. Now let us go back to SSMS and see how we can do that using SQL. So this is the same table which we have created in SSMS. Now let us start with a select rows, select. Now we'll take all the records from the table from the input table, which is fp underscore friend underscore request. Paste it here. Now we will write a where clause, where action equal to send. So this is the first table that we are going to use. We have reduced the records such that in this query we are only fetching the records corresponding to action sent. Similarly, let us copy this query, let us paste it here, and instead of send we will write accepted. So this is the second table that we are going to use, that is the table corresponding to action accepted. Now we have created 2 separate tables, one corresponding to action sent and the other corresponding to action accepted. Now let us join these 2 tables. Before joining these 2 tables, we can rename the date column in both of the tables, such that in the first table where action is sent, we can rename the table date as date sent, and in the second table where action is accepted, we can rename the date column as date accepted. So let us rename the column and let us write the column names explicitly instead of writing star. User underscore ID underscore sender, comma, the second column is user underscore ID underscore receiver, comma, now it's date column, and the date column we are going to rename here as date underscore sent. So this is the first table. Now in the second table, we are going to rename the date column as date accepted. Copy this, we'll paste it here and change this date sent to date accepted. Now we have the two tables which we created separately for action sent and action accepted. Now let us join these two tables. So we will put the first table in the parenthesis and give an alias name as A, and let us put the second query inside another parenthesis, and we will name the column as B. Sorry, name the table as B. Now let us write a left join. Left join. After the alias name B, let us write the join condition, that is A dot user ID sender copy equal B dot user ID sender, because both the tables are having same column, which is the user ID sender column. And also we have to write one more condition, that is A dot user ID receiver. Copy this. A dot user ID receiver equal B dot user ID receiver. Now we have completed the join condition part. Now let us go back to the start of this query and select only columns which are required. That is select user ID receiver column, user ID sender column, comma, and these two columns let us take from subquery A. Now we will take the two other columns which are date sent and date accepted. Date sent, comma, date accepted, and write a from clause. Now let us execute this and see what we are getting. Now this table has become more meaningful. Now we have a user ID sender column, user ID receiver column, date on which the friend request was sent, and date on which the friend request was accepted. If the friend request was not accepted, the date accepted column will be having null. Now this table looks more meaningful, and now it is very easy to calculate the acceptance rate from this table. Now let us put this entire query inside a CTE with T1. Let us name the CTE as T1. Let us put this entire query inside a CTE. Now write a select clause after the CTE definition, that is select date underscore send as date. So we'll name the column as date. Now we are going to count the number of date accepted records, that is count date accepted divided by count of date underscore sent. Now before running this query, we have to write a from clause, and before that let us convert this part into a float, because otherwise we will get 0 in the result, as acceptance underscore rate, and this is taken from T1 CTE, and we have to write a group by clause since we have some aggregate function in the query. So date sent will be written in the group by clause. Now if we run this query, we will get a acceptance rate which is in ratio. Run this, and we have the date on which the friend request was sent and the acceptance rate with respect to that particular sent date. Now if we want to convert this to percentage, simply multiply it with 100 and it will get converted into percentage. Let us do that also. Do 100, execute this. So on 2020-1/4, we have acceptance rate of 75%. Similarly, for the second record, that is 2021-6, we have a acceptance rate of 66%. So this is one method of solving this question. In this video, we will see how to ungroup data in SQL. This is ungrouping and not unpivoting. So unpivoting and ungrouping are two different operations, and in this video, we will see how to ungroup data. Since this is not related to pivoting, we won't be able to use any unpivot function or operations similar to unpivoting to do this ungrouping. Instead, we will use a new concept called as recursive SQL to ungroup data in SQL. So this is our input table. So our input table contains three columns. The first column is ID column, the second is an item column, and the third is a total count column. This table tells us the number of items in a particular store. That is, for ID 1, the item is pen and the total count of items within that store is 2. And when coming to pencil, the total count is 1, and coming to book it's 2, and umbrella it's 3. And now this is grouped data. Now we have to ungroup this data and create a table in this manner, where pen is repeating 2 times, that is corresponding to the total count, and pencil is repeating 1 time, book is repeating 2 times, and umbrella is repeating 3 times based on the total count. So this operation is called as ungrouping. Now let us go to SSMS and see how to do this in SQL. So this is the exact same table which I have created in SSMS. That is the store sales table. And this is the table which we saw in Excel. Now we have to ungroup this data and create an output which is similar to our expected output. Let us start writing the query. As I said earlier, here the concept we are going to use is recursive SQL. For recursive SQL, the first thing we want is a base query. So let us write the base query first. That is select. We want all the columns from the input table. The first column is ID, second is item, and the third column is total count. So these are the 3 columns which are required, and this is taken from the store sales table. Let us copy this, paste it here. Now we have the base query. Instead of writing the recursive SQL query for entire table or entire items, let us first write for a single item and then let us expand it to all other items. For that, after the from clause, I will write a where clause. Actually, this where clause is not required for the final output, but for simplicity, first we will write the recursive SQL for a single item and then we will remove the where clause. Here, we will take only pen and write the recursive SQL query. So let us write a where clause where item equal to pen. Now this is the base query for recursive SQL. Let us execute this, and this is our base SQL query. Now we want to write the second part where we are writing a condition based on which recursive query will happen or recursive operation will happen. So for that we will have to write a union all clause, and after that we have to write one more select clause, and here the columns which are required are ID, item, and the next column is total underscore count minus 1. So based on this condition only, recursive operation will happen, and we'll give the column name as total count, because in both the queries column name should be same, and this is taken from the recursive query. Let us name this as R1, and let us put this entire query inside a parenthesis. So starting from the first query, that is the base query, including union all, and the second query which is the recursive query, let us put all the things inside a parenthesis, and at the beginning of the parenthesis we will use a with clause and give the name for recursive query, that is R1, as the query inside parenthesis. Now we have completed the recursive part. Now after this from clause, inside the query we have to write a where clause based on which the condition should terminate and the query should give us final result. So here we will write where total count, copy, greater than 1. Let us write this condition. Now after this is like a CTE expression only. So we have to write one more query outside so that we can fetch result from the CTE R1, which is recursive CTE. Select, we want ID and item from the R1 query, from R1. Now let us execute this and see what is the output that we are going to get. Execute this. Now we can see that pen is repeating 2 times as we saw in our output. So pen is repeating 2 times. Now we wrote this recursive SQL query only for pen. Now let us remove this where clause, because we don't want the result for pen only. We want the result for entire input table. Now let us execute this once again. Execute. Now we can see that we have more records in our output, and also one more thing we can do in order to compare our result. Let us order the final output based on ID, order by ID. Now execute once again. Then let us compare our output with the expected output. Copy this and let us compare this with our expected output. Now we can see that our output which we have obtained in SSMS and the expected output is matching, and we have successfully ungrouped data. This is how we can ungroup data using recursive SQL. This is just one application of recursive SQL, and there are many more applications of recursive SQL and which are more complex than this application. In this video, we will solve a tricky SQL interview question. The question is, recommend pages for a person based on the pages liked by his friends. And there is a condition given, that is, don't recommend pages already liked by the person. In order to solve the question, we have to rely on two tables. The first table is friends table and the second table is likes table. I have created the exact same table in Excel. Let us examine the table and then let us solve the query. This is the friends table, which consists of two columns. The first column is user ID 1 and the second column is user ID 2. The friends table tells us who are the different friends of different user IDs. So if I take the first record as an example, 1 and 2 user IDs are friends. And if I take the last record from the friends table, we can say that 6 and 1 user IDs are friends. So friends table tells us who are the different friends of different user IDs. And coming to likes table, it has got two columns. The first column is user ID 1 and the second column is page ID. And this table tells us what are the different pages liked by different users. For example, user ID 1 has liked the page 88. That is, the page ID is 88. And coming to record 2, user ID 2 has liked the page which has got a page ID of 23. So this is the likes table tells us. Now let us go back to SSMS, and here is the DDL and DML to create the table in SSMS. You can create the table. It will be provided in the description. Now coming down, I have created the exact same table here. Let us query the tables, and these are the two tables which we saw in Excel. And for simplicity, we are going to find the pages or the recommended pages only for a single person. So the question is, write a SQL query to recommend pages to the user with user ID 1 using the pages that his or her friends liked. And it should not recommend the pages that are already liked by that particular person. Now we have to find the recommended pages for user 1 based on the pages which are liked by his friends. And we should not recommend any pages which is already liked by the user ID 1. So this is the question that we are going to try and solve in this video. Now let us start writing the query. The first thing here what we have to find is we have to find all the friends for the particular person. So we can split this question into actually 2-3 parts. The first portion is to find all the friends of user ID 1. So let us find all the friends of user ID 1 first. So select, that is taken from the first table, that is the friends table. So we have got two columns, user ID 1 column and user ID 2 column. We can see that user ID 1 column has got the user ID 1 repeating 3 times, and if I come to user ID column 2, we can see that user ID 1 is repeating 1 time. So 2, 3, 4 user IDs are friends of user ID 1, and also 6 is a friend of user ID 1. So 2, 3, 4 and 6 users are friends of user ID 1. So we have to get that result first. So user underscore ID 1 from which table? The table is friends table. Now we have to give a where condition, where user underscore ID 2 equal 1. Now we will get the user ID 1 corresponding to user ID 2 equal to 1. That is, from the column user ID 1, we will get all the friends of user ID 1. Execute this, and now we will get the friends of user ID 1 from the user ID first column. Similarly, we have to find all the friends of user ID 1 from the second column, that is the user underscore ID 2 column. For that, we will use a union clause, then copy the same query, and instead of this user underscore id 1, we will change it to user underscore id 2, and in the where condition we will change it to user underscore id 1 equal to 1. Now if we execute this, we will get the records from user underscore id 2 column, that is 2, 3 and 4 are friends of user id 1. Now if we combine both the queries using a union clause, we will get all the friends of user id 1. Now these are the friends of user id 1, that is 2, 3, 4 and 6. Now we found the friends of user id 1. Now we have to find all the pages liked by these friends. For that, let us keep this query inside a CTE given us. Okay, now we found the friends of user id 1, and now we are going to find all pages liked by the friends. For that, we are going to use the table likes table. Select star from likes, and in the where condition we have to specify the condition based on the first CTE. Before that, let us query the likes table 1, and let us see what are the columns in the likes table. So these are the two columns which are users underscore id column and page underscore id column. Now in the where condition we have to specify where users underscore id in, and within parenthesis we have to write a select clause, and inside the select clause we have to specify the column name, that is the user id 1. And before specifying the column name, for making this more understandable, let us name these columns within the CTE ones. So as friends, here also we'll name the column as friends. Okay, now we can use this column name inside the parenthesis within the where clause friends, and this is taken from T1. So we have the where condition. Now execute this query starting from the CTE. Start from here and execute this. We will get all the pages liked by his friends. Yeah, now we have all the user IDs and pages liked by the friends of user ID 1, and we don't want both the columns, we only want page ID column. So page underscore ID, and also we will put a distinct clause because the page IDs are repeating. Execute this once again. Let us see what is the result. Execute this, and we have page IDs 23, 24, 33, 56, 77 and 88. But in the question it's given that do not recommend a page which is already liked by that particular person. So if we inspect the likes table once, we can see that page 88 was already liked by user ID 1. So do not recommend that page once again to the particular user. So we don't want that result or that page ID in the output. So we have to remove that. Now for that, we will use a left join. So before writing a left join, let us put this inside a CTE. It is for making the query more understandable. Otherwise we can write it here only, but let us put this inside a CTE so it is more easy for understanding. T to us, and putting this entire query inside a parenthesis, and select from T2, and now we will use a left join. We are going to left join the likes table, and likes table, so sorry, before left joining the right table we don't want to directly join the likes table. We will select the page ID belonging to the user ID 1, that is select page underscore ID, and before this we will use a distinct clause also, distinct page ID from likes, and we will use a where clause where users underscore ID equal to 1. And now we have a subquery for the left join, and put this inside a parenthesis and give an alias name which is A, and now we are going to write the join condition, that is T2, and before that on T2 dot page ID equal A dot page ID, and inside the select query we will specify T2 dot page ID comma A dot page ID. Now if we execute this, let us see what we are getting. We will get both page ID columns from the likes table and the first CTE, that is the T2 CTE. Now we have the page IDs from the CTE as well as the likes table. Now we want to write one more condition, that is write a condition where a dot page ID equal null. That time this record will be deleted from the result. So what we can do here is where a dot page underscore ID is null. Now execute this and we will get the pages recommended for user ID 1 and which are not liked by user ID 1. Execute this, and now we have page ID which are not liked by user ID 1 and which are liked by his friends. And these are the recommended pages for that particular person. Also, we don't want this null page ID column in the result, so we can remove that as well. We have commented out that second page ID column, and now we don't have that in the result. Execute this once again and we will get only one column with the page IDs recommended for person with user ID 1. So these are the page ID which are recommended for the person. In this video, we will solve a complex SQL interview question. The question is, create a fixture such that each team play with every other team only once. That is the first question. And the second question is, create another fixture where each team play with every other team twice. So for that, I have created a table. The table is called as team table and it has got two columns. The first column is team code and the second column is team name. So based on this table, we have to create a new table that is a fixture table where each team play with every other team once. That is the first part. And in the second part, each team play with every other team twice. That is the second part. So we have to write a query to get that fixture. First, when I read the question, the initial thought that came to my mind was, let me do a cross join. But cross join will not work here. Let us see why that is not working first. Because I think most of the people will be going for cross join approach when we hear about this question. Please select star from team underscore table. Let this be the first table and we'll do a cross join, same table, T2. Now execute and we will get an output. But the question is, each team play with every other team only once. But once we inspect this table, we can see that the first record, India is playing with the same team code that is India. That will not happen. That is the first condition which does not satisfy when using cross join. And the second condition is Australia is playing with India. That is a valid condition. But when we come down, we can see that there will be a second record where India and Australia are again playing. So this is another violation of our condition. Our answer should contain a fixture where each team will play with every other team only once. That is, India and Australia combination should appear only once in the output. Similarly, every other combination should appear only once in our output. And a team should not play with the same team also. So that is the condition we have to satisfy when writing the query. For that, let us start writing the query. So cross join will not work. Let us comment this out. So we'll start with a select clause. Select. We will take the team code only because both team code and team names are unique. So we'll take team code only to create the fixture. So team code, we want team code. Now after this team code, we will use the row number function to provide a unique ID for the team codes. Row number and over. We don't want any partition here, just a order by clause. Order by team code only. Whatever be the order, it does not matter here. The only thing is that we have to provide a unique ID to each of the team code. This is the unique ID column. So let us give the name as ID only. And this is taken from the team underscore table. Now execute this and we will get a new column along with team code where each team code has been assigned an ID. So this is the first part. Now let us put this inside a CTE. Put this inside a CTE with team as, let us name the CTE as team. Now coming down, we will create a join between team and the same team. That is kind of a self join. Select from team, that is the first table. Now join, again team is joined and we will give an alias name to both the tables so we can distinguish the tables easily. So the first team can be named as team only, the second can be named as opponent. Opponent, and the join condition is on team.id greater than opponent dot id. So this is the join condition. And now in the output we require two columns, that is the team code from the teams table and team code from the opponent table. Sorry, opponent dot team underscore code. So these are the two codes which we require in our output. Now we have completed our query. But before running the query, let us rename this columns once again. So this is team 1 and the team code from second opponent table, let us name as team 2. Now execute this. The number of records in our output should be 10 and let us see what happens. Now we have an output where we can see that every team is playing with every other team only once. So England and Australia is playing one game, and again if we check the entire table, we will not be able to find any record where the same combination is repeating. Similarly, India and Australia is playing one game, and again India and Australia are not playing any game in the same tournament. So we have successfully created a fixture where we satisfied our condition, that is each team play with every other team only once. Now let us move on to the second part, that is each team play with every other team twice. So from this output only we will get to know that so every each team play with every other team only once. We have 10 records in our output. So when each team play with every other team twice, the number of records in our output will be 20. This is just for a quick validation. Other than that, this explanation regarding the number of records does not imply anything. This is only for quick validation. Now coming to second part, let us copy this entire query because we are going to make only one small change and we will get the output. Now we have the same CTE where we created an ID based on the row number function, and we have created a self join with the CTE table which we created, that is the team, and we have created a non-equi join, that is team.id greater than opponent.id. Now we are going to make a small change in this join condition and we will get the required output for the second part. So instead of this greater than, we will write not equal to. During that time, each record from the team table will join with every other record other than the same record. So execute this and we can see that we have a new fixture where each team is playing with every other team twice. So we can see that the first record is England Australia. Again coming down, we'll be able to find one more record where England Australia is repeating. Let us check that this is Australia England is again repeating, that is they are playing twice. Similarly, India and Australia, coming down we can see that India and Australia are playing again. So in this fixture every team is playing with every other team twice. So we have successfully created our output. In this video, we are going to convert multiple row data into a single row data which is concatenated and delimited. As an example, we have a teacher subject table which has two columns. The first column is teacher and the second column is subject column. So this table maps each teacher to different subjects they are handling. And in the second output table, which is the expected output table, we want the output such that each teacher should have only one row and the subjects should be concatenated and delimited by a delimiter. So for example, if we take this Amy as an example, Amy is handling two subjects, geography and history. And in our output table, we can see that we have a single row for the teacher Amy and the subjects are concatenated, delimited by a delimiter. So when checking the input table, we can see that there are four different teachers handling different subjects, and coming to our expected output table, we have only four rows and each row corresponds to each teacher. Now let us go to SSMS and write query for the same. So this is the teacher subject table which we saw in Excel. So I have created the same table in SSMS. So now we want to convert this table into the expected output format. So for that, let us start writing the query. We will start with a select rows, and the first column which we require in our output is the teacher column, and the second column is subjects which is concatenated and delimited with a delimiter. For that, here we are going to use a function called as string aggregate function, that is string underscore agg function, and inside the parenthesis we have to specify the column based on which we are going to aggregate the strings.
Here the column is subject. Let us give a name for this column, that is subjects. Now from this is from the input table teacher underscore subjects. Now let us run this query and see what is our output. Now we will get an error because string function requires two argument. One error is because string function requires two argument. In our question itself, it is given that we have to specify a delimiter. So the second argument should be a delimiter. So let us give the delimiter as /. Yeah. Now let us execute this. Execute this. Column teacher subject dot teacher is invalid in the select list because it is not contained in either an aggregate function or group by clause. So since string aggregate function is an aggregate function, we have to provide the group by clause within the query, that is group by teacher. Now execute this and we will get the output. But once we go and check the output, we can see that the subjects for each teachers are ordered in ascending order. So if I come to the Leslie teacher, we can see that the subjects are ordered in ascending order, that is literature, psychology and sociology. And coming to our output which we obtained, we can see that this result is not ordered in ascending order. For that, we have to add one more condition in the string aggregate function similar to a window function. So we have to write a within group clause, and inside parenthesis we have to write order by subject in ascending order. Now if we execute the query, we will get the output which we saw in our expected output. Execute this. Now we can see that each of the subjects for each teachers is ordered in ascending order. And this is how we convert multiple row data into single row concatenated and delimited data. In this video, we will see how to calculate the popularity percentage of different users on a social media platform. So our question is, find the popularity percentage for each user on Meta or Facebook platform. The popularity percentage is defined as total number of friends for the user divided by the total number of users on the platform. And then finally, we have to convert the result into percentage by multiplying with 100. And there is one more condition: output each user along with their popularity percentage. So the final result should have two columns. The first column is user ID and the second column is popularity percentage for each users. And one more condition is there, that is order results in ascending order by user ID. So that is our final condition. So for this, I have created a table called as Facebook underscore friends. Let me query the table and let us see the schema. So we have a table with two columns. The first column is user1 and the second column is user2. And this column tells us who are the friends of different users. For example, friend 1 is a, sorry, user 1 is a friend of user 2. Similarly, user 4 is a friend of user 1. And coming down, we can see that again 5 is a friend of user 1 and 6 is a friend of user 1. And when we look at the entire table, we can see that user 1 is having 4 friends, which are 6, 5, 4, 3 and 2. Sorry, not 4 friends, 5 friends. So these are the friends of user 1. Similarly, we have to count the number of friends for each users. So let us start writing the query for the same. So the first part is to count the number of friends for each users. So we'll start with a select clause user1 and give an alias name as users. And now we have to count the number of distinct users with respect to user2 column. Distinct user2 column has friend count. So we'll give the column name as friend count, and this is taken from the table Facebook underscore friends. Let us copy the table name, and finally we have to give a group by clause based on the user one column. Now we have completed the first part with respect to user one column. Similarly, we have to do the same query to user two column, and then we have to count the number of friends with respect to user two column also. So let us run this part of the query and see what is the result we are getting. So taking user one column in this query, we get the friend count as 3 corresponding to user 1, 2 corresponding to user 2. Similarly, 3, 4, 7 and 8 are having 1 users each. And now the same query we have to repeat for user 2 column.
So let us copy this query, paste it here, and the only change we have to make here is make this user 1 user 2, and now we have to count the number of distinct users based on user 1 column, and also change the group by clause based on user 2 column. Now this query will count the number of distinct users based on user 2 column. So this is the number of friends based on the user 2 column. So we have computed the number of users, sorry, number of friends based on user 1 column and user 2 column. Now we have to combine the result of both this query. So here what we have to do is we have to append the result. So we will use a union all clause. Now execute this and we will get a appended result where we can see that users and friend count is in separate column, but we have to aggregate the user count, sorry, friend count based on each user ID. For that we will place this query inside a CTE first with t1 as, place this inside a CTE, write a select clause outside the parenthesis taking CTE1 as the reference or t1 as the reference, that is users is the first column. Now we are going to use the aggregate function which is sum, and the second column is friend underscore count. So friend underscore count as total friends. Now this is taken from the CTE T1, and finally write a group by clause based on the users column. Now execute this and let us see what is the result. Starting from the CTE, execute this. Now this table gives us the number of friends for each users. So now we can see that user 1 has 5 friends, user 2 has 3 friends, user 2 has 3 friends, user 3 has 3 friends. Similarly, till user 9 we have counted the number of total friends. Now we have to find the number of total users from the table. From this table itself it is obvious that the number of total users is 9. So for that, in the same query we will write one more column, that is, here we are going to use another concept called as subquery within column specification. So inside the parenthesis select count of distinct users. Now from the table T1 close the parenthesis, and this is the total users, and this will give us a new column where the total users will be the sum of individual users within the table. So we'll execute this once again. We can see that one new column will be created with total users. Execute this, and the number of total users is created in a separate column. Now we have to divide the total users and total friends column. That is, total friends divided by total users will give us the popularity percentage. So in the same query, we will take that as a separate column. So sum of friends, copy this, paste it here, divide by the query within the column specification, copy and paste it here as popularity underscore percentage. Now execute this and let us see what is the result. Now we are having some error, incorrect syntax near T1. Sorry, it's because we have a query before the CTE. So this query should be terminated with a semicolon. So instead of that, let us comment this query out. So now if we run this, we will get the result. We haven't made any change to our query, but the error was because there was a query before the common table expression query, which should be terminated with a semicolon. But instead of terminating it with a semicolon, I just commented out the query. So we have only one query to run in this file, which is the CTE query. Execute this and we have the result. Now we have the popularity percentage as 0 here because we have to convert this numerator part into a float. So for that, we will use the cast function, cast sum of friends as float, and finally we will multiply this with 100 and we will place this inside a parenthesis. Now once we execute this, we will get the result. Execute, and we can see that we have the popularity percentage. But one more thing we will do here, we will round the result to 2 decimal places, round, comma 2. So execute this and we have the popularity percentage as a separate column along with users, total friends, total users, and finally popularity percentage, which is rounded to two decimal places. And there is one more condition which is given in our query, that is we have to order the final result based on the user ID. So we will take user ID column here in the order by clause. Order by users in ascending order. Also in the final result, we require only two columns, which are user ID column and the popularity percentage. The total friends column and the total users column can be removed in our final result. Execute this, and finally we will have our result where we have users and the popularity percentage of each users. In this video, we will see a tricky SQL interview question. The question is, find the number of times each word appears in draft. Output the word along with the corresponding number of occurrences. For that, I have already created a table called as Google underscore file underscore store. And this is the data the table is having. It has got two columns. The first column is file name and the second column is content. And the file name has different types of files. The types are draft and final. So we have to find the number of times each words are appearing in the draft file names. So we have to split the content such that each word is split into different rows, and then we have to count the number of times each words are repeating in the draft. And this is our input table, and our output should look like this table where the values or the words inside the content is split into different rows, and we are counting the number of occurrence of that particular word. Now let us go back to SSMS and see how we can achieve this result. The file name is called as Google underscore file underscore store. That is, select star from Google underscore file underscore store. Let us query this table and see what the table is having. The table is having the exact same data which we saw in the previous Excel file. So this is the table. Now we have to convert this table such that each words in the content is split into different rows. For that, we are going to use a function called as string split here. Let us see how we can achieve that. We will start with a select clause, and before writing any argument inside the select clause, we are going to write a from clause based on the Google underscore file underscore store. And the string split function actually we have to use along with the from clause. For that, one more concept we have to use, which is called as cross apply. So we will write a cross apply function here. Then after cross apply, we are going to use the string underscore split function, and inside parenthesis we are going to specify the column name, which is the content. Then after this we are going to specify the delimiter based on which the splitting should happen. So here it is the space, open and close single quotes along with a space, and now we have the string split function. And now in the argument, sorry, in the select clause we have to specify a function called as value. Then we can give an alias name for this value column as words. Now let us run this query and see what is the result we are getting. Execute this. Now we have the words split into different rows. Also in the question it's given that we only have to consider the draft. So we have to write a where clause where, and the first column from the Google file store. Let me query the table and let me take a look at that once again. It is called as file name. So file name like, and inside the single quotes we have to specify draft and followed by a person sign, and it is file name. Now run this and we will get only words from the file name draft. Execute this. Yeah, we have the result. Now we have to count the number of times each words are repeating. For that, we will place this query inside a CTE with T1 as open and close parenthesis. And now we are going to write another select clause based on the CTE T1. Select words, comma, count star as number of occurrence, and this is taken from the table T1 or CTE table T1. Now we have to write a group by clause based on the words column. Now execute this and we should get the result. Execute. Now we have the intended result where we have words as the first column and number of occurrence of different words as the second column. This is how we can achieve the result which we were looking for. And the tricky part here is the cross apply function, then string split function. In this video, the question is, Write a query that will calculate the number of shipments per month. The unique key for one shipment is a combination of shipment ID and sub ID. These are the two columns which are present in our table. Output the year month in format YYYY hyphen MM. That is the format in which we have to return the year month. And the final column in the output, that is the number of shipments in that particular month. For this, I have created a table called as Amazon underscore shipment. Let me query the table and let us see the schema and then write the query for the same. So this is our table, which is the Amazon underscore shipment table, which has got four columns: shipment ID, sub ID, which is basically the customer ID or the subscriber ID, and this is the weight of each shipment, and finally we have the shipment date. Now our question is to write a query that will calculate the number of shipments per month, and the output should be in the format of YYYY and MM. Now let us start writing query for the same. Also, it's given that unique key for one shipment is a combination of shipment ID and sub ID, which means when we are counting the number of shipments, we have to count the shipments such that we have to count the distinct combination of shipment ID and sub ID. Now let us start writing query for the same. We will start with a select clause. Now we want to extract year and month from the shipment underscore date column. For that, we will write year function, and inside that we'll specify the shipment underscore date column, which will give us the year. Then we have to concatenate this with the month of that particular shipment date. For that, we will write a concat function at the beginning of year function. We will place this entire year function along with the shipment date inside the parenthesis, followed by another expression which is an hyphen. Then after that, we will write the month function, and inside parenthesis we will specify shipment date, which will give us the month of that particular shipment date. Now close this, and we will give an alias name as year underscore month. And this is our first column. Now we have to count the number of shipments. For that, we will write count, and inside parenthesis we are going to concat shipment ID and sub ID, that is shipment underscore ID comma sub underscore ID, and this will be the count of number of shipments. So number of shipments is the column name. Now this is taken from the table Amazon underscore shipment, and after this we will specify the table name, which is Amazon underscore shipment. Let me copy the table name, paste it here. Now after that we have to specify a group by clause because we are using the aggregate function count. So therefore we have to write the group by clause along with the concat year and month column, that is group by. Copy this entire function and paste here in the group by clause. Now if we run this query, we will get an output where we will have a column called as year month and the number of shipments. Execute this. We have a output where we have year month as the first column and number of shipments as the second column. But there is a problem with this output because in the question it's given that we have to return our output in this specific format. So ideally our output should have been in this format, which is 2021 hyphen, and then it should be 08. It should not be simply 8, it should be 08. And when coming down, 2021 09 should be the second row result for year month. But we have a different year month combination in the output, which will not be always accepted. So let us see how we can achieve the exact same result which we want. For that, let me copy this same query. We are going to make a small change in this query where instead of this concat function, remove this. We are going to use another function called as convert function. Convert, open and close parenthesis. Now we have to convert that shipment date column into a variable character column. Variable character column, and I'm using a variable character column of length 7. Now, and the second expression that we have to specify is the column name, that is the shipment date, shipment underscore date. And the third column is the format to which we have to convert that specific input. So I'm specifying here 120. There are different styles into which we can convert using the convert function. You can refer that in some documentation, because there are multiple formats to which actually we can convert using the convert function. So here I'm going to use the style 120. Then in the group by clause also I'm going to replace this function with the convert function. Copy this, paste it here. Now let us run this query and see what is the result we are getting. Execute this. Now we have the same intended result which we are looking for. That is, we have the output year month in format YY, YY and MM. Now this is our output. We have year month and number of shipments in each year and month. In this video, we will solve a data analyst interview question which is commonly asked for companies like Flipkart, Amazon, Big Basket and similar e-commerce platform companies. The question is, find returning active users for an e-commerce platform. So we have to write a query that will identify returning active users. A returning active user is a user that has made a second purchase within 7 days of another purchase. Output a list of user IDs of these returning active users. So we are given a table called as Flipkart underscore transactions. So this is a table which I have created. Let me query the table and let us see the schema and then let us solve the query. So this is the table which we are going to use, which consists of columns, ID, user ID, item, created at. Created at means the transaction happened on that particular date. And finally, we have a column called as revenue. And now from this table, we have to find the returning active users. And a condition is also given here. So a user is considered returning active user when he has made a second purchase within 7 days of any other of their purchases. Let us start writing the query. So we'll start with a select clause, select, and now we are going to select all the columns from the Flipkart underscore transaction table. So I'm giving an alias name as ft dot star. Now this is from the table Flipkart underscore transactions. Let me copy the table name, paste it here. Now here we are going to find the difference between the latest purchase and the previous purchase date for each customer ID. Sorry, yeah, customer ID. It can be user ID or customer ID. So here it's user ID. So now we are going to find that. For that we are going to use the function called as lag. Using lag function, and inside the lag function I'm going to write the arguments. So the argument will be created at. Now in the over clause we will specify partition, that is partition by user ID, user underscore ID, and order by clause is based on created at, which is in ascending order. Created at in ascending order. And this is the previous purchase date for each transaction with respect to a user ID. So we have created a window with respect to user ID, and we are now creating a new column called as the previous purchase date, and then we can compare the previous purchase date and the actual purchase date to see if the difference between the two dates are 7 or not. So we'll give the column name as previous purchase date. Once I execute the query, it will be more clear. I'm executing this. Column prefix ft does not match with the table name. So it is because I haven't given the alias name in the from clause. Now it will be fine. Execute this, and now we will get a new column called as previous purchase date. And now we can see that for each customer ID or user ID as a partition, we have created a new column called as previous purchase date. So if I take the first record where user ID is 100, we can see that the created date is 2023/7. The next purchase happened for that user was on 2023/13. And coming to the previous purchase date column, we can see that the record 2023/7 is appearing here, which means the user ID 100 has made his previous purchase on that particular date. And coming down, we can see that this 2023/13 is coming in the next row, which means 2020 corresponding to the record 2020/03/18. This is the previous purchase date. Similarly, for each users, we have created the previous purchase date with respect to each transactions. Now let us keep this query inside a CTE, that is CTE1 as. And now we are going to find the difference between the previous purchase date and create date. We will write a select clause, select, and the column which we require are user underscore ID, then created at, comma, then previous purchase date, Then we are going to find the difference between previous purchase date and created at. For that, we are going to use the function called as date diff. And inside we have to specify the interval, then starting date and the ending date. So here it will be day, then comma, after that the second argument, which is the starting date, that is previous purchase date, then the third argument will be the created at date. And this is the difference between the previous purchase date and created date. I will give a column name as diff date, and this is taken from the CTE1. Now if we execute this, we will get another result where we can see that we have a column called as user ID created at previous purchase date and date diff. From this we can identify that if that user is making a purchase within the 7 days gap, that is, once a user has made a purchase, if a user is again making a purchase within the 7 days, we can identify from this date diff column. And for that, here we will write a where clause where we will copy this entire function, copy this, paste it here. Now we will write which is less than or equal to 7. Now execute this and we will get records for which where date diff is less than or equal to 7. Execute, and now we can see that date diff for every record is less than or equal to 7. Now here we have to only find the users which are returning, so we does not require all these columns in the output. For that we can place this query also inside a CTE, which is CTE2. And now from the CTE2 we will take only the user ID. From CTE2 simply write a group by clause which will give us the distinct user ID who are returning. Now execute this and we can see that all these user ID will be the returning customers user IDs. So all these customers are the frequently returning customers who are making frequent purchases within a gap of 17 days. Sorry, not 17 days, 7 days. In this video, we will solve a complex SQL interview question. The question is, Julia asked her students to create some coding challenges. Now, write a query to print the hacker ID, name, and the total number of challenges created by each student. Sort your result by the total number of challenges in descending order. Now, here is the tricky part. If more than one student created the same number of challenges, then sort the result by hacker ID. Hacker ID is basically the student ID. If more than one student created the same number of challenges and the count is less than the maximum number of challenges created, then exclude those students or hacker ID from the result. Now, these are the two tables which we are going to use, which is the hackers table and challenges table. And also, while solving the query, we will split this question into two parts. The first part is where we will find the total number of challenges created by each student. And in the second part only, we will deal with the specific condition, because once I create this query output or the first part output, then I can explain with that part what we are going to modify or what we are going to change with respect to that output to obtain our final output. So these are the two tables which we are going to use. The first table is hackers table. Let me query the table and let us see the schema. This is the hackers table, which consists of two columns. First column is hacker ID and the second column is name. Hacker ID is basically the student ID and the name column corresponds to the student name. And in the second table, which is the challenges table, we have two columns. The columns are challenge ID and hacker ID. Hacker ID is again the student ID only, and challenge ID is the ID of challenges created by each student. Now, the first part of question is write a query to print the hacker ID, name, and the total number of challenges created by each student. For that, now we are not going to take anything from the hackers table, because in our final output, it is given that we require the name of each student. Only at that time we are going to take the hackers table. So here we are not going to touch the hackers table. Instead, we will take the challenges table to find the answer to first part of our query. Write a query to print the hacker ID and the total number of challenges created by each student. This is pretty simple. So what we can do is we will write a select clause. Now we want the hacker underscore ID column. Now we are going to count the number of challenges based on each hacker ID, that is challenge underscore ID as We will give the column name as challenge count, and this is taken from the table challenges. And now finally we will give a group by clause based on the hackers id, hacker underscore id column. Now if we execute this result, we will get the output for the first part of our query. So this is the output for the first part of our query. Now we have a condition in the second part of our query. If more than one student created the same number of challenges, then sort the result by hacker id. So that is okay. We can sort the result by hacker id by providing a simple order by clause, that is order by hacker underscore id. Let it be in ascending order. Now we have sorted the result based on the hacker id when challenge count is same. This is not correct. I have to make one more change, because first we have to sort the result based on challenge count. Challenge underscore count in descending order, then sort the result based on hacker id if it's equal. Now we will get the result in such a manner. Execute this. We will get the result in such a manner where we first sort the result based on challenge count, and if challenge count is equal, then the result will be for that particular challenge count will be sorted for hacker id in ascending order. Now the second part is, if more than one student created the same number of challenges and the count is less than the maximum number of challenges created, then exclude those student or hacker id from the result. Now in order to explain this, I have created the same result in Excel. Let us go to that and see what we are going to do. Now this is the output which we have obtained in our previous query, and if we inspect this result, we can see that hacker id 1 and 2, that is 12299, is having a challenge count of 6, and the second hacker id, which is 34856, is having a challenge count of 6. And coming down, hacker id is 70978 and 79345 is having challenge count of 4 each. And this is the records which we have to exclude from our final output. That is the condition. If more than one student created the same number of challenges, that is, in both the cases, students are creating same number of challenges. In the first two records, that is 6, and the third and fourth record, that is 4. And the count is less than maximum number of challenges created. Here, the maximum number of challenges created is 6. So we don't have to remove these records, because given that only if it's less than maximum number of challenges created, we have to exclude those records. And finally, then exclude those student or hacker id from the final result. So we have to exclude these two hacker ids from our final result, and our final result should be in such a format where we have only 4 records and the condition is satisfied. Now let us go back to SSMS and see how we can achieve this. And in the same query, now we are going to write a count function. Let me remove this order by clause for now. We will add that in a later stage. Now I am going to consider the count function as a window function and is going to create a new column based on the challenge count column. Let us do that. Count 1, and using an over clause, and the partition is based on partition by the challenge count column. But I'm going to use this function which is count of challenge id. Copy this, paste it here, close this, and we'll give a name as new window or new flag. New flag, the column name is new flag. Now if I run this query, we will get a new column called as new underscore flag, where it is counting the number of challenges. So corresponding to 6, the challenge count is appearing 2 times, and corresponding to 4, the challenge count is appearing 2 times. Corresponding to 3, it is appearing only 1 time, and corresponding to challenge count 1, it is appearing only 1 time. Similarly, I'm going to create one more column based on the rank function. Rank, open and close parenthesis, over. Now here I'm not going to create any partition. Instead, I'm only going to use a order by clause, order by challenge id. So instead of using challenge id column directly, I will copy the function count of challenge id, paste it here in descending order as new flag or new rank. I will give the column name as new rank. Now execute this and see what is the result that we are going to get. Now we have created new column, which is the new flag column and new rank column. Now let us keep this entire query inside a CTE. Open and close parenthesis. Now we filter the result such that we will get only the required output in our final result. So we'll take hacker underscore ID from the T1 CTE and we require challenge underscore count, comma. For now, we'll take other two columns also, which is flag and rank column. Later, we will remove that. That is rank column, and this is taken from T1 CTE. And now I'm going to apply a where clause where new underscore flag equal 1 or new underscore rank equal 1. Now what will happen is this records or this result will be filtered such that we will get these two records where new rank equal to 1 and these two records where new flag equal to 1, and these records corresponding to challenge count 4 each will be excluded from our final result. Now execute this and see what is the result we are going to get. Executed. Now we can see that in our final output we only have hacker ID and challenge count corresponding to new flag 1 and new flag rank. It is an OR condition, so either of the records will be selected. And also in our question it's given that we require the name of the student in our final output. So we will make the modification to this part of the query. Now we will create a left join with T1 from the hackers table. We will give an alias name as H on T1 dot hacker ID equal H dot hacker ID, and here also we will give the alias name because otherwise it will give us an error. Challenge count we don't have to give any alias name because challenge count name is unique in the T1 CTE. Then the second column or the other column which we require is the name column, which is taken from the hackers table H dot name. Now also we will order the result by challenge count in descending order, and if two challenge counts are same then we have to order the result based on hacker ID in ascending order, and this hacker ID also will take from the T1 CTE. Now execute this and we will get all the required columns in our output plus the order in which we require our final output. Execute this, and this was the final output which we are looking for. In this video we will solve a pretty complex SQL interview question. The question is, you are given a table task containing three columns: task ID, start date and end date. It is guaranteed that the difference between the end date and start date is equal to 1 for each row in the table. So this is our first condition. And if the end date of the task are consecutive, then they are part of the same project. The manager is interested in finding the total number of different projects completed. Then write a query to output the start date and end date of projects listed by the number of days it took to complete the project in ascending order. If there is more than one project that have the same number of completion days, then order by the start date of the project. So that is the required output we are looking for. For that, I have already created a table called as task. Let me query the table and then I will explain the question once again, then it will be pretty clear. So this is our table called as task, which consists of three columns, that is task ID, start date and end date. Now I have created the same table in Excel so that we can do some minor analysis on Excel itself and then come back to SSMS and replicate the same in SQL. Let me go to Excel and let us see the first condition, that is it is guaranteed that the difference between end date and start date is equal to 1 day for each row in the table. So here I have created the same table. So when we go through each of the row, we can see that the difference between start date and end date for each task is 1 day. So for the task ID 1, we can see that the start date is 1/10/2024 and the task end on 2nd/10/2024. Similarly, the second task is starting on 02/10/2024 and ending on 03/10/2024. Similarly, we can see that for each row, the start date and end date, the difference is 1. So every task is taking only 1 day to complete. So that is the first condition. Now coming back, this is the second condition, that is if the end date of the task are consecutive, then they are part of the same project. Now let us see that in the table. So When we go through the end date, we can see that this is 2 10 20 24, then it is 3 10 20 24, then it is 4 10 20 24. After 4 we can see that it is 14. So up to 4 these are consecutive end date. So we can say that task 1, task 2 and task 3 are part of the same project. Let me highlight it with a different color. So these are part of a same project. Now coming down, we can see that another task which is 4 is ending on 14 10 2024, and the next end date is 15 10 2024. So this is also part of the same project. So let me highlight that as well with a different color. So let it be blue. Then the sixth task is starting on 28 10 2024 and ending on 24 10 2024. And when looking at the end date, we can see that the next end date is 31 10 2024. It is not 30. So these are not part of the same project. So these are part of different project. So 6 alone is a project and 7 alone is another project. So these are two other separate projects. Now our question is, write a query to output the start date and end date of project listed by the number of days it took to complete the project in ascending order. So now our output, what we are looking for, should look like this. So the start date column, then we have a end date column, which is the second column, and the third column is number of days it took to complete, that is number of days. And our output should be in a format where we have the start date 01/10/2024 for the first project with respect to task ID 1, and the end date should be 4/10/2024 because these three tasks are part of the same project, and the task with respect to that project is starting on 01/10/2024 and is ending on 04/10/2024. So this should be the first row, and 04/10/2024 should be the end date, and number of days it took to complete should be 3. And then for the second project it should be 13/10/2024 the start date and 15/10/2024 the end date, and the number of days it took to complete should be 1. Sorry, it is 3, and now here it is 1. And now similarly we can see that for task 6 the start date is 28/10/2024, and since that task itself is corresponding to a project, there is no separate end date, we can take the same end date. Sorry, this is not 1, it is 2. Then coming down, the difference is 1 day, that is number of days it took to complete is 1 day. And similarly for the task ID 7 we have start date 30/10/2024 and 31/10/2024 with a number of completion days 1. So this is our expected output. And finally there is one more condition, that is if there is more than one project that have the same number of completion days, then order by start date of the project. So this satisfies that condition, that is number of days is same 1 to complete the projects, and we are ordering the result based on the start date in ascending order. Now let us go back to SSMS and write query for the same. So we have the same table which is created called as task. Now we are going to write a select clause based on which we are now only going to fetch start date which is not available in the end date column, that is start underscore date from task table, where start underscore date not in inside parenthesis we will write a subquery, that is select end date from the same table task. So now if we run the query, we will get start date whichever is not available in the end date column. Before that we need to add one more column using the row number function, that is row number over, and we don't want any partition here, we just need an order by clause, that is order by start date in ascending order as row underscore 1. So I'm giving a name called as row underscore 1. Now if we execute this, we will get start date whichever is not available in the end date column in the task table, and we will place this inside a CTE. Before placing this inside a CTE, let us write one more query which is similar to the query which we wrote. So here we will fetch the end date whichever is not available in the start date column. So instead of start date we change it to end date. So here also order by end date in ascending order and here where end date not equal to or not in, select start date. So whichever end date is not available in the start date column, we will be fetching using the second query. So execute this and we will get a result where we have two columns. The first column will be end date and the second column will be row underscore 2 corresponding to each of the end date. So this is our second query. Now let us place the first query inside a CTE called as T1 with T1 as open and close parenthesis. Now after that we will place the second query also inside a CTE, that is T2 open and close parenthesis. Now we will join the two tables, that is T1 and T2 we will join here. From T1 we will create a join T2, that is T1 dot, sorry, we have to write an on T1 dot row underscore 1 equal T2 dot row underscore 2, and we will give a star here so that it can fetch all the columns. Now execute this and let us see what is the result we are going to get. Now we can see that we have a result which is almost similar to what we are looking for. So now we have the start date and end date corresponding to each of the project. So we have the start date 2024-10-1 and the end date of that particular project is 2024-10-4. Similarly, we have the same for all four projects. Now we want the difference between end date and start date corresponding to each of the project. For that we will use a date diff function, date diff, and inside we will specify the interval, that is day, and the start date is start date column which we took from the T1 CTE, and the second column is end date column which we took from the second CTE, that is T2. Here since the names are different we don't have to provide the alias name, otherwise it would give us an error. Date diff as number of days. Now execute this, we will get an additional column where we have the number of days it took to complete the project. So corresponding to the first row we have 3, second row we have 2, and third row we have 1, and fourth row we have 1. That is the number of days each project took to complete. And now we have to order our final result based on the number of days it took to complete in descending order. That is, copy and paste it here in descending order, and if the number of days are same we have to sort it based on the start date in ascending order, ASC. And also before executing this, in our final result we require only start date and end date. We does not want the row 1 and row 2 column, that is start date comma end date column. Now we have completed the query. Now let us execute this and see what is the result we are getting. Before executing, let me make a small change, that is it is not simply order, it is order by. Yeah, now execute this and we will get the result which we are looking for. Execute this, and now we have the start date, end date, and number of days of each project, and this is the exact same result which we are looking for. Let us copy this and let us simply compare it with the result. So this is the start date column, this is the end date column, and this is the number of days it took to complete. We can see that we have the exact matching result which we were looking for. In this video we will solve a complex SQL interview question. The question is, given a table of purchase by date, calculate the month over month percentage change in revenue. The output should include the year month date in this format and percentage change, rounded to 2 decimal points, and sorted from the beginning of year to the end of year. The percentage change column will be populated from the second month onwards and can be calculated using the below formula, that is, this month revenue minus last month's revenue divided by last month's revenue multiplied by 100, which will give us the percentage change with respect to the previous month. So for that, we are going to use a table called as sales transactions. So this table contains many number of rows. So writing DDL and DML for this table is actually not very feasible. So what I'm doing here is I'm simply exporting the CSV data as a flat file into SSMS. And the file link from where you can download will be given in the description. So you can simply go ahead and download the file and replicate the same steps. So here we are importing the data into the database called as int underscore queries. For that, right click on the database and select task, then import flat files, and then click on next. And now we have to choose the file from which we are going to import the data. So the file name is This is the file which we are going to export into SSMS, that is sales underscore transactions. Now click on open. The new table name is sales underscore transactions and the table schema is by default DBO. Now click on next, and now we have four columns, that is ID, created at, value and purchase ID. Now click on next. Now we can see that we can choose the required data type here and also assign primary key and the null constraint in this modify column dialog box. So here the ID can be nvarchar, so that is fine. Created at, let it be date only, so we don't want the time part in the date column, so let it be date. So let me go and choose date. Now value, let it be int, and purchase ID also let it be int. So there are no nulls in the table, so we don't have to select allow nulls. Then click on next and finish. Now insert data is successfully completed. Now click on close. Now let me execute this select top 10 star from select transactions and see if the data is executed successfully. Execute this. Now the data is executed successfully into the new table called as sales underscore transactions. So these are the four columns which are available, that is ID, created at, value and purchase ID. Now here we have to find the monthly percentage revenue difference between different month. So first what we have to do here is we have to calculate the monthly revenue for every month. For that, first let us write a query for the same. We will start writing a select rows, select, and before writing the columns from which we are going to fetch the actual data, let me write the from clause also, that is sales underscore transactions. So this is the table name. Now we want to fetch the year and month part from the created at column. For that we are going to use the function called as convert function. Instead of using any date function, we are simply going to use the convert function to fetch the year and month from the created at column in the respective format. So here we are converting into nvarchar and let the length be 7 comma, and the column or the expression from which we are going to fetch the month and year is created at underscore at, and the third one is style. So here I am going to give 120, which is the preferred style as year underscore month. So if you want a more detailed idea about this convert function and the way in which we are going to convert a date column and fetch year and month from the date column, you can go ahead and see the previous video where I have explained this method in detail. So now after this, we want the sum of value with respect to each year and month, that is sum value, open and close parenthesis, and giving an alias name as current sales underscore sales. Also, since we are using an aggregate function, we want a group by clause also, that is group by. Copy the entire function starting from convert to the end of parenthesis, copy and paste it here. Also we will order the result by created underscore at in descending order, sorry, in ascending order. Now execute this and see what is the result that we are going to get. Column sales underscore transaction dot created ID created at is invalid in the order by clause because it is not present in the select clause. So we can directly go ahead and use this convert function along with the parenthesis, sorry, along with the arguments. We don't have to use the created at column. Now execute this and see what is the result we are going to get. Now we have the first part of the output, that is now we have aggregated the total sales for each year and month. Now we have to find the difference between the current month sales and the previous month sale. For that we want a new column where we are going to fetch the previous month sales. For that let us put this query inside a CTE. Even that is not required, we can even write the same query over here. So I'm not going to use the CTE concept here, we will write the same query here. So this is current month sales. Now we want the sales of previous month. For that we will use the lag function. So inside the parenthesis for lag function, we are going to use sum of value, open and close parenthesis, and now we are going to use the over clause over, and here we don't have to give any particular partition but simply give an order by clause based on the same argument which we have provided for the group by clause. So here over, copy this order by inside the parenthesis for lag function, paste it here in ascending order. Now this is the previous month sale, that is previous month underscore sales. Here also let us give current month sales, that is current month sales, and the third column is previous month sales. Now execute this and see what is the result we are getting. Now we have a new column which is created, which is giving us the previous month sales. Now in the question itself, it is given that the percentage change column will be populated from the second month forward. Sorry, the second starting from the second month. So here for the first month, previous month sales will be null. Obviously, because before the first month there are no sales which is happening. So here it is null. Then and can be calculated using the formula, that is this month revenue, that is current month sales, minus last month's revenue, that is previous month sales, divided by previous month sales, which is multiplied by 100. Now let us try to do that. Let me paste this query inside a parenthesis, that is sorry, inside a CTE, open and close parenthesis. Now inside the CTE we don't want the order by clause. If we place this order by clause inside the CTE, we will get an error. So outside the CTE, we will write a new query where we are going to calculate the difference between current month sales and previous month sales in percentage. So the first column is year underscore month, comma, and here we are going to apply the equation, that is current underscore month underscore sales minus previous underscore sales, sorry, previous underscore month underscore sales. So this is the first part, which is divided by the previous underscore month underscore sales. Now this is multiplied by 100 into 100. This is the percentage change, percentage underscore change. Now this is taken from the CTE T1, and now we will order the result based on the year month column, that is order by year underscore month in ascending order. Now execute this and see what is the result we are going to get. Now we have obtained a column called as percentage change, but here all the values are 0 because here this column is considered as an integer column. That is why we are getting the result as 0. For that, we can simply multiply the numerator part by a 1.0, that is a float number, and get the output, that is 1.0, sorry, 0 into the numerator part, which will give us the output in the record format. Now we can see that we have the percentage change with respect to each year and month. But in the question it's given that we have to round the result to 2 decimal places. For that, what we can do here is we will convert, that is convert into decimal, open and close parenthesis. Let the scale be 10 and precision be 2, that is number of numbers after the decimal, that is 2, comma, and this is the record expression or the column, and let the third parameter, and here we don't have to provide any third parameter because it's simply converting to decimal, so the style parameter is not required here. So we can simply run this and get the record output. Now we can see that we have the record output in the record format in the record order. The first column is year month and the second column is percentage change. Now coming to the year month 2019 2, we can see that there is a decrease in sales with respect to the previous month, that is 28.56 percentage less compared to the previous month. And coming to 2019 3, which is the third month, we have a increase of 23.35 percentage of the total sales. And now we have obtained our record output. We will solve a conceptual SQL interview question, something which is very similar to Pareto rule but not exactly Pareto rule. So the question is, find the least number of product and list the product that contribute to 80% or more of the total sales. So for that we are given a table which is the Walmart table. Let us execute the query and see what is the schema. So here is the table which has got product ID, name and sales column. And from the table we can see that each of the records are unique. That is, each product ID and name is unique with respect to the Walmart table. And this is the sales corresponding to that particular product and product ID. And now in the question it's given that we have to find the least number of product and list the product that contribute to 80% of more of the total sales. So we have to calculate a cumulative sales column, along with that a cumulative percentage sales column, and from that we have to identify which are the product which contributes to 80% of more of the total sales, and given one condition, that is we have to find the least number of products. Now let us see how we can write the query to get the result. So we will start with select. The first column that we write here is product name. Since the product ID and name both are unique, we will only write your product name. Product name. Second column will be sales column. Third column will be an expression with respect to sum analytic function. So here we will use the sum aggregate function as an analytic function. That is sum of sales over open and close parenthesis, and inside that we will specify the order by clause, order by sales in descending order, and there will be a second column based on the order by, that is product id, which should be in ascending order. That is fine, either ascending or descending should be fine. And this column will be named as cumulative sales, and this is taken from the table Walmart table, from Walmart. Execute this and we will get a new column which is the cumulative sales. This is the cumulative sales with respect to the Walmart table. Now we have to find another column which is the total sales with respect to entire store. For that, sum of sales over, here we don't want to specify any order by clause. Instead, we will write a partition by open and close parenthesis, and inside the parenthesis simply write a select null, which will give us the total sales as total underscore sales. Execute and we will get one additional column as well, which is the total sales. So you can see that the last record corresponding to cumulative sales and the total sales will be equal, that is 18,900, and the total sales also will be 18,900. Now we have to find a new column, that is the percentage of sales corresponding to each product. For that we will write one additional column, that is sales divided by this expression we will copy, that is sum of sales over partition by select null. Copy, paste it here as percent sales. Then execute this query, but there will be a small correction. We will see how we can do that. So we have the percentage sales, but every percentage is 0. It is because the sales column is considered as an integer, hence the result is also coming as an integer. For that we will multiply the numerator with 1.0, hence it will be considered as a float and we will get decimals. Now we can see that we have the result. So we will multiply the entire expression with 100 so that we have the result in percentage. Multiply by 100 and execute this. Now we can see that we have the percentage sales, that is laptop corresponds to 39% of the total sales, then smartphone corresponds to 31% of the total sale. Similarly, furniture corresponds to 13% of the total sales. And now we will place this query inside the first CTE, that is with percent underscore sales as open and close parenthesis, and we will place the entire query inside the first CTE. Then select star, and we will write one additional expression based on the percentage sale column. So here sum of open and close parenthesis, and inside the parenthesis the expression will be percent underscore sales. So we can calculate the cumulative percentage over order by the same column, that is percent underscore sales in descending order as cumulative underscore percent. This is taken from first CTE, that is percent underscore sales CTE. Execute and we will get a new column with the cumulative percentage. From here we can easily identify the number of product or the list of product which contributes to 80% or more sales, given that is least number of products. So we will place the second query also inside another CTE, that is cumulative percent as open and close parenthesis, select. We require only few column. The first column will be name, second column will be sales, third column will be cumulative percentage, cumulative underscore percent. Now this is taken from the CTE cum underscore percent, and now we will write a where clause, where
cumulative percent less than or equal to 80. Now execute and we will get the product which contributes to 80 percentage of the total sales. That is least number of products. Execute. Before executing, we will comment the select statement which we have initially. That is select star from Walmart. So we get the result only. So we have the result where we have only laptop and smartphone. Together they contribute to 71 percentage of the total sales, and laptop alone contributes to 39 percentage of the total sales. Now if we make a small change to the percentage over here, we will get additional record as well. So in order to get products which contribute to 90 percentage of the total sales or less than or equal to 90 percentage of the total sales, execute and we will get laptop, smartphone, furniture and headphone. So all the four product together will contribute to 88 percentage of the total sales. So this is how we can obtain the number of product and the products which contribute to different percentage of the cumulative sales. We will solve a tricky SQL interview question. So the question is, obtain the output in the required format. So this is the question. So we have to analyze the input and the output, compare the input table with the output result, and we have to write a query to get the output in the required format. So for that, we have created a table which is the subject info table. Let me execute this and we will see the schema. So we have two columns. First column is class and the second column is subject. Now let us go and see what is the expected output and then how we will obtain the expected output. So here is the expected output I have created in Excel, and this is the exact same input table which we saw in SSMS. Now let us compare the input table with the expected output table and see what is the relationship between the input and output. So we have two columns. The first column is class and second column is subject. At the first glance, we can see that this is something like a pivot operation. But there is one more condition that was given in the question, that is we should not be using any pivot to solve the question. And using pivot also, we will not be getting the exact result. So without using pivot function, we will have to write a query to get the output in the required format. Now let us compare the input table with the output table. So we have two class within the class column, that is A and B. So the same two records can be found in the expected output table, that is A and B. Now corresponding to that, we have created five different columns, that is subject 1, subject 2, subject 3, subject 4 and subject 5. And with respect to class and subject, we have to populate the value of subject, that is either max, English, social or whichever subject is corresponding to that class, we have to populate in the expected output table. But there is also one specific order in which we have to populate the output table. So when we compare the table, class A, subject max. So this is the first record. Then taking a look at the class B and subject corresponding to that subject 1, we can see that it is social. So where can we find social? So when we go through the table, here we can find one social, but there is another record which is corresponding to class B and the subject is social. Here the class is A, so this is not the record that we are going to look. So this is the record that we are going to look. So social and max should be the subject 1. So first record corresponding to class A and last record corresponding to class B. So that is the first subject, subject 1. And coming to subject 2, we can see that class A, social. So this will be the subject 2 corresponding to class A, and the second subject is max. Class will be B and the subject will be max. So this is the subject corresponding to subject 2 and class B. So it is kind of reverse order. So we have to populate the class A row such that the subject is appearing in ascending order, and for class B we have to populate the subject such that the subject are in descending order with respect to the input table. So that is the logic that we have to use in the given question. Also, there is one more thing that we have to notice, that is there is no specific order that is given in the input table. So we have to assume an order or the order in which the table is available in the database, and based on that we will have to write the query. Now let us go back to SSMS and see how we can write the query to get the output in the required format. So here we have the table which we already queried, the same input table. Now we will start writing the clause. We will start with select star from subject table, that is subject underscore info table. Now we will write a row number function, window function, that is row underscore number, open and close parenthesis over, and the partition should be based on class. Partition by class. Let the column name be flag.
Now execute this, but we will get an error. So that what we will do here is partition by. Now we will write the order by close. Order by, we will open and close a parenthesis, and inside the parenthesis we will specify select null. So what this does is, it will consider the order in which the table is provided or available in the database. Now execute this and we will get a result. Execute, and we have a result where we have a new column, that is a flag column. Now based on the flag column, class column and subject column, we are going to create 5 different additional columns. So for that we will place the first query inside a CTE1 as open and close parenthesis. Now we will write another select clause. Select, the column which we require are class, second column will be subject, third column will be flag, and now we are going to write the next column which will be based on a case statement, that is case when flag equal 1, then subject, else null, and end the case statement, and this will be named as subject1 as subject1. Similarly, we will have to write 4 more case statement based on which we will get 4 additional column. So we'll copy the case statement 4 times. So this will be second case statement, that is case when flag equal to 2, then subject, else null, end the case statement, and the column name will be subject2. Similarly, for flag 3, subject name will be 3, then for flag 4, subject will be named as subject4. Here the final column, flag is 5 and subject name will be subject5. That is, the column name will be subject5. And this is taken from CTE1. Now execute and we will get a result where we have 5 additional column along with the column which we have already, that is class, subject, flag plus 5 additional column. Execute this and we have 5 additional column along with the already available columns. Now we will place this query inside a CTE, that is a second CTE, comma CTE2 as open and close parenthesis, and now we will write a select, and now we are going to make use of a aggregate function. So class will be the first column and second column will be based on an aggregate function, that is max of, it can be either max, min, average, or whatever aggregate function you want to use, you can use. You will get the same result. So subject1 as subject1, that will be the first column. Second will be max of subject2 as subject2, that will be the second column. Third will be max of subject3 as subject3. Similarly, 2 more column, that is corresponding to subject4 and subject5. So we will copy the same expression, paste the expression. Now this column name will be subject4 and max of subject4, and the final column will be max of subject5 and column name will be subject5. And this is taken from CTE2, and we will write a group by clause, group by class. Now execute and we will get the result that we were looking to obtain. So this is the result now we have obtained. Let us compare the result with the expected output result that we initially saw. So we will copy the result, paste it here. Now compare the result. So we have the same headers, that is class, subject1, subject2, subject3, 4 and 5. And when we go through the record corresponding to the columns, class will be class A and B, subject will be max and social corresponding to subject1, subject2 social max, then subject3 physics statistics, subject4 biology chemistry, subject5 science and English. So this is the result that we were looking to obtain, and we got the exact same result. So we obtained the result without using any pivot function or any other complex function, using a simple window function, that is the raw number function, and the case statement, and using one aggregate function we have obtained the result. This type of questions are commonly asked for companies dealing with logistics and transportation network. So we will go through a similar question and see how we can solve the question. So our question is, analyze the frequency of ride during peak hours compared to the non-peak hours. So given peak hours is the time between 7 a.m. to 10 a.m. and 5 p.m. to 8 p.m. This is the peak hours. Now we have to write a SQL query to calculate the total number of rides and the average fare during peak hours and non-peak hours. The result should be displayed in a format, that is time period along with total, right, and average fare. So we should have finally three columns in our final output. That is, the first column is time period, which consists of two value, which is peak hours and non-peak hours, and then another two column which are total ride and average fare. This is the format in which we have to obtain the output. Now there are two conditions which are given, so we can identify what is a peak hour and what is a non-peak hour. So ride with ride date time between 7 a.m. to 10 a.m. and 5 p.m. to 8 p.m. are considered as peak hours. Now coming to non-peak hours, rides with ride date time outside those particular range is considered as non-peak hours. So we have to remember this condition while solving the question. Now let us query the table and see what is the schema that we are given. Execute this, and we have a table called as rides table, and it has got ride id, ride date, ride distance, and ride fire. So we are given a table with 4 columns. Now let us go and see what is the format of our expected output. So this is the exact same table which we saw now in SSMS, and this is the format in which we have to obtain the final output. So like explained earlier, we have a time period column in which we have two value, which is peak hour and non-peak hour. Then we have another two column which are total ride and average fare with respect to each time period. Now let us go back to SSMS and see how we can solve this question. Now we will start with a select clause. Select the columns which you require are all the columns from the right table. So we will give star from rights table, and now we have to find the time period in which the write date is falling. So for that we are going to make use of a function which is the date part function. Date part open and close parenthesis, and inside we will specify the argument. The first argument should be the date part itself. So here we require hour as the date part. So hour, then the second expression should be the write date. That is the column from which we are trying to obtain the particular date part, and this will give us the hour with respect to that write date column. Execute and see what is the output we are getting. So we have a new column which has the hour with respect to write date column. Now we have to write a case statement based on the HR column which we created. Now we will write a case statement, case when. Now we are going to make use of the same function, copy, and between 7 and 10 it is belonging to the peak hour. And also there is one more condition, that is 5 p.m. to 8 p.m. is also considered as peak hours. So we will write that condition also in the same case statement. So we will place the first condition within a parenthesis, and we will write the second statement, which is date part hour between 5 p.m. 5 p.m. and 8 p.m. Now we have to convert that to 24-hour format. So 5 p.m. will be 17 and 8 p.m. will be 20. Now place this also inside another parenthesis, and if either of the two conditions are satisfied, then the value should be peak hour, peak underscore hour. Now also make sure that we have to write the or operator between the two conditions. So either of the condition should satisfy, then that particular instance will be falling within peak hours. Now coming down, we will include the condition for non-peak hours. So else non-peak hour, end the case statement. Now we will give the column name as time period, time underscore period. So this is the new column which we created based on our date part which we obtained from the write date column. Execute this and we will get one additional column which is the time period column. We have a new column which is the time period column, which is now specifying either the ride is falling within the peak hour or non-peak hour. Now we will paste the first query inside a CTE with peak or non-peak CTE. So this is the CTE name as open and close parenthesis, and the entire query is within a CTE. Now we will have to write a aggregation based on the time period column, that is time underscore period. Now we want the number of total ride, so we will count the number of ride id, count ride underscore id, which will give us the ride count, ride underscore count, and then we can obtain the average fare from the ride fare column. So average of ride underscore fare, which will give us the average fare underscore fare. Now this is taken from the first CTE, that is peak or non-peak. Copy the CTE name. Now we will write a group by clause, group by time period column, time underscore period. Execute this and we should get the required output. Execute and we have the required output.
So we have a time period column with the two value, which is non-peak hour and peak hour, and we have ride count corresponding to each time period and average fare with respect to each time period. Now we can see that from analyzing result, the number of rides with respect to non-peak hour is only 5, but when it comes to peak hours, the number of ride is 15. But average fare almost remain constant. It does not change much with respect to time period. That is, either it is peak hour or either it is non-peak hour, the average fare remain constant. Hope you like the video. Thanks for watching, and if you like this video, subscribe our channel. Thank you.